All right, we're back. It's gonna be another learning Rust stream. So no more messing around this time. Last time was pretty fun though. Thanks to everyone for stopping by. And we're gonna continue learning Rust. Let me see what I did here because I want to show. Yeah. All right, let's try showing the chats on stream too. Apparently this is TOS for Twitch and YouTube, but you can't combine them. It's not TOS for Twitch. But in any case, we got the setup. It's a nice Friday evening. We got the beer too. Let's start. Let's continue learning Rust. And I left off with what? Tuple. Yeah, I left off with Rustlings. I somehow distinctly remember this was pretty easy. Okay, we're already like a quarter of the way in. I think it's gonna get hard. Today I want to do structs. Right? Yeah, you would think that's number 7 here, but if we go to the... let's see. Learning Rust by example. And the Rust book. Yeah, this is all we need. The Rust book and learning Rust by example. I see. So custom types, structures. Enums. So, okay, we got to start from here. And here we'll keep this one in the back burner. Yeah, okay. Let's do it this way. Let's see what... Let me see. Let me try redoing the Rustlings. Can I go back? L. Okay, I can't go back. Okay. Let me do the quiz then. Sure. R. C. Okay, I see. So current exercise quiz 1. Yeah, let's redo this one. This is just as a recap. This is a quiz for the following sections. Variables, functions, if Mary is buying apples. Price of the apple costs $2. Mary buys 140 apples. Price of each apple is reduced to only $1. More than 40 apples. FN calculate. Alright, so let's write. So U32, right? And it takes apples. U32. And it says if apples less or equal to 40, and it was else. Okay, I remember the syntax. So we want to directly return apples. Mary buys more than 2 times apples if it's less or equal to, otherwise it's apples. All right, that's it. Okay, so pretty easy. If this is a grand quiz, I guess it's basic Rust syntax. Now speaking of basic Rust syntax, let me see. Let apples U32 is 24. Let cost U32 is calculate price of apples. Okay. Print line. Mary will pay comma, cost. Yep, Mary will pay 48. Good. So remember the print too. And I believe the debug print was this. Okay, in which case for U32 it has a nice debug trait, so we're seeing the same thing. I don't remember much else then. This must be pretty basic then, what we covered. Primitive types, booleans, if is morning, is evening, char, single quotes versus string. Char is alphabetic, is numeric. Oh, Unicode char actually, or whatever this thing is. Okay, what else do we have here? Oh shit, arrays. An array called A with at least 100 elements in it. Yup, so 200 instantiated with 0 200 times. Because we have to initialize arrays in Safe Rust, right? There's no other way around it. Aha, slices. Cat. This is a pattern or a deconstructed tuple, what we would call it in Python. Okay, indexing a tuple is easy. All right, let's move on to Vex then. Okay, we are, let's see. So if I go next, okay, it is Vec 1. Okay. Before we tackle this one, let me see the README. Vectors are one of the most used Rust data structures. Not for my language, they simply called arrays, but since Rust operates on a bit of a lower level, an array is stored on the stack, meaning it can't grow or shrink. So it's a compile time thing, okay? And the vector is stored in the heap. Okay, so it's dynamically. Vectors are a bit of a later chapter, but we think that they're useful enough to talk about them a bit earlier. Okay. Weird order. What should we do here? So they want to talk about vectors. Let me consult the manual. Damn, these are so different though. Like, where the heck do I have types? No, the exercises are structured differently than the Rust by example book completely. I see, so we had arrays here and slices, okay? So arrays are known at compile time. And slices, but their length is not known at compile. Slices are not vectors though. Although this kind of sounds like a slice is sort of a vector, maybe, possibly. So where the heck are vectors then? Damn it. Okay. Oh my god, they're all the way over here in chapter 19. There's no way. Alright, let me read this quick then, I guess. Yeah, the order is a bit weird in the rustling exercises. They kind of jump around. Let's give this a shot though. Vectors are resizable arrays. Okay. Aha, so I was right. So they are close to slices, which is not a bad guess. They can grow or shrink at any time. A vector is representing three parameters: pointer to data, length, capacity. Okay, so they're kind of fat pointers. They also have a capacity. Oh, but it's like a very inner thing. So vec collected into, okay, I don't know the syntax, but I guess this is an iterator collected into, okay. And I'm guessing it's gonna print, okay, never mind. Fix me, comment out this line. Aha, there's an out of bounds index there. Oh no, there's two wrong lines. Okay, so collected 0, 10 into, okay, so we gotta learn this. Well, we know the slice notation, it's like Python. So last index, okay. The vec can be used to initialize a vector. Also, it is extremely similar to an array, except it's initial vector of 1 with the length of 2 and the capacity of 3. Okay, so it should be 1. And we're gonna use the sane person notation, okay. And then I insert new element at the end of the vector, push. It should be 1 and 4, obviously. I cannot insert anything into the immutable vector, which I guess I'm supposed to know that this collect thing returns an immutable. Oh no, because it's not let mute, duh. Oh, okay. So if I do let mute here and I can push a 0, then I'll see, let's see. Oh, right, I need to print it again. Duh. Okay, so it worked. So, collected iterator, mutated, okay. And it's the debugging print. Oh, God. Oh, I can't type the question mark in this stupid website. And we print again, collected iterator. Yes, nice, we fixed it. Okay, so it was just a mute, obviously. Okay, so I can make a mute vector. Okay, I can push a 4, I can push a 0. The length will give me the length of this guy, which is 2 at this point. Obvious. Wait, why is the initial vector? Oh my God. It's 1, 2, 3. Okay. Can it not just be 1, 2, 3 like a normal human being? Alright, so my guess was wrong. It's not the initial element, the length, and because you can't have uninitialized stuff in safe Rust. Alright, what else? Length of this 3. Indexing, this is exactly Python. Second element is 2. Pop removes the last element from the vector and returns it. So then if I print the vector is now XS, I should see 1, 2, 3, pop a 3, 1, 2. No, that's wrong. It's 1. Okay, so pop is not like Python. Wait, really? Oh my God, no, it's 1, 2, 3, 4. Okay, it is a pop. Yeah, So it's 1, 3, 4, and I pop the 4 back. I'm back at 1, 2, 3. I can't access the 4th element anymore because I just popped it, obviously. I could insert something back. Vectors can be easily iterated over. It's exactly like Python. For x and xs iter, print line. Sure, 1, 2, 3, contents of x. Vector can be iterated over while the iteration count is enumerate. Okay, it's exactly like Python enumerate. Wow, they actually ripped Python off. Wild. Nice, Rust. So it gives you the iterator I in position I, we have value, obviously. Iter mute. So I can iterate while mutate exactly like a Python list, like in place. Okay, so pretty basic. Vectors are pretty basic. More vec methods can be found under the standard vec module. All right, so what does Rustlings want us to do? So all right, let's read the list. Let's read the book too then. The first collection type we'll look at is vect. We already read this. Vectors allow you to store more than one value in a single data structure. Puts all the values next to each other in memory. It's good to know. Vectors can only store values of the same type. They are useful when you have a list of items, such as the lines of text, sure, which would be a vector of strings, or the prices of items, a vector of floats or something, to create a new empty vector. All right, so there's a constructor new, which I think everything in Rust has this, trait. Let's use the right name. I guess they call it function. Method? I don't know. Function. Function associated to the data type vec. We added a type annotation here. This is true. So we can type annotate the vector before, not eagerly, but declare it. This is important. Vectors are implemented using generics. The vect type can hold any type, probably including vectors, you would think, obviously. When we create a vector to hold a specific type, we can specify the type within angle brackets. Okay, this is good syntax to know. In listing 8.1, we told Rust that the vect in V will hold elements. I don't understand why they don't call it a vec I32 here, but sure. More often, you'll create a vec with initial values, and Rust will infer the type, so it works eagerly too. So you rarely need to do. Rust conveniently provides the vec macro, which we saw in the other exercise, which will create a new vector that holds the values you give it. Listing 8.2 creates a vec 1, 2, 3. The integer is I32 because that's the default integer. Yeah, we know this from last time, okay? Because Rust can infer in the type annotation. Updating a vector. Push, we saw this. Push last, okay? If we want to be able to change its value, we need to make it mutable. Yeah, we saw this too. I guess it doesn't matter after the first push. This locks the data type in anyways, right? So this sentence is a bit off. It should read the first number we place inside is of type I32. So we don't need a vec I32 annotation. Otherwise, if I try to put a something 6.5 here, I'll probably get a compiler error. Maybe it's time. Let me Rust Playground. Let me actually check that. So let's see. So updating a vector, create a vector. So then I can just do this, right? Yes. Okay, so then if I try to push a 6.5, yeah, mismatch types. Okay, makes a lot of sense. All right. Mute. Reading, there are two ways to reference a value stored in a vector: indexing or using the get method. In the following examples, let me go back to Rust Playground. We've annotated the types of values that return for extra clarity. 1, 2, 3, 4, 5. Obviously, I32 already. Okay, so the syntax here is a bit freaky, but I'm guessing, let me try to simplify this myself. So what's happening here? Third element is 3. Why do I need to do this reference? Can I not just do this? I can. Okay, so I don't need a reference to... Okay. I see. Get 32 gives me a reference to I32, or does it give me an I32? No. It must be a reference. I see. So these are exactly the same thing. I see. So get is the same thing as getting a reference with indexing, except it unpacks into an option, which if I put a 16 here, I'll bet you this still compiles. Yeah. Okay, so we're jumping ahead a bit because I don't know what Rust options are, but I can guess from this syntax, which is pretty helpful. So it's a deferred check, basically. It could be an I32, a reference to an I32, or it could be none, in which case I'm guessing before I do anything with it, I must specialize it with this match. And this is an expression that returns either this or none. No, this is just a match though. Okay, so we'll learn about options later then. We use the index value 2 to get the third element. So as you're using reference in brackets gives us a reference to the element. When we use the get method with the index passed as an argument, okay, we get an option. Okay. Rust provides these two ways to reference elements so you can choose how the program behaves when we try to use an index value outside. As an example, let's see what happens when we have a vector of 5 when we try to access an element. Obviously, this is not going to work. Oh, but this is not a compiler, it's a panic? Really? It is a panic. Because the compiler doesn't know, oh, right, because it's a vector. It doesn't have a value known at compile time. It's not an array. What was it called? I forget the other data type. Oh. All right, yeah, an array, but it has to be annotated like this with brackets and semicolon. Okay. And what happens if I do the get? This runs because this was not yet used. It's an option, right? So I haven't yet done anything with it. Pretty smart, okay. So we can use the hard indexing method when we want the program to crash. We can also use the get method to return none without panicking. You would use the vaccine method may happen occasionally under normal, right? So it's business logic. Your code would then have logic to handle having some or none. Okay, we don't know what those are, but we can kind of start guessing. When the get method is passed an index, it returns none, okay. If they accidentally enter, okay. For example, the index, yeah, okay. So this would be more user-friendly. When the program has a valid reference, the borrow check reinforces the ownership and borrowing rules, which we did not know about yet, but it's fine, to ensure that the reference and any other references remain valid. You can't have mutable, immutable in the same scope. So this is a basic borrow checking. I guess it's not the worst to learn a bit about this. So, okay, so I'm already done here basically, right? Because I take a v and I take the first. So I have a mutable vector. I borrow a reference immutable to the first element, and I try to push something, so I can't. So what I can do is I can write the scope here, and this goes out the scope, and now this is gonna work. All right, but of course, like this, because it's out of scope. So now this works, But then if I put these together, if I take the scope out, even though I changed the thingy here, interesting, this still works. So it's where I do the print. It's because why? Because I don't know the borrow checking yet, probably. Interesting. When the program has recall that the rule we can't have mutable and immutable references in the same scope, where we hold an immutable reference and try to add an element. This program won't work if we also try to refer to that element later in the function. So if I comment this works. I see. I can't refer to it after I mutated the same array out of which I took a reference, because Rust doesn't know at compile time. I could have dropped this, for example. So anytime I touch this, there's no guarantee that this exists, right? This could have been, so here's the better example, right? This could be the last element, and I pop the last element, and then obviously the last element sorry, pop is just the last one. There we go, yeah. So of course I can't do this, but I can do this. I can look at the last one and then mutate the array. And okay, I understand borrow checking, because it was 5 at this time in the program, but obviously if I try to take last, so now what I can do is, what if I try to do the smart thing? So now it's gonna panic, okay? So let's try this again. Still compiles, runtime panic, okay. So now I can do the smart thing and I can say get, try to get something. And let me just annotate these. This is I32, and this will be, no, this is a reference to I32. And this is a possibly a reference to an I32. And the option doesn't implement, I can't print it, but I can debug it. There we go. So now everything compiles and it runs without panicking. That's because, but I do get the none, which I didn't specialize yet. But now I can match on it and I can print. Okay, so I can do a match last. And if I do see a reference, I'll print I can print without debug mode. And if I see a none, we are out of bounds. Let's see if I got this right. I must have, right? Ooh. But why? Isn't this specialized? Why does it say option doesn't implement format display? What was the example here? Damn it. So where are the methods of vec? Oh, it's some. It's because I still don't know the Rust IC. So if it's some reference to I32, and some I still can't print. Like, it's not guaranteed to be. Oh my god, no, it's because I'm trying to print last again, obviously. I don't know how to specialize this then. How did they do it here? Oh, some third. So it's some last. Interesting. Okay, I need to learn this some syntax. So I match last, and if it's anything, in this case, I guess this is the peeling of the option. That's what that means. Some peels option, or some cancels out the option. Interesting. Yeah, so I obviously still don't know the Rust syntax. Okay, good. So we can go back to vectors. Okay, reading elements. Yep, so we went through this, we went through this, we played around here. The code. Why should a reference to the first element care about the changes? But because it doesn't know at compile time, right? Oh, actually, it is even more detailed than this. So because vectors put values next to each other, adding a new element onto the end might require allocating new memory at runtime and copying the old elements to a new space. So then the reference, the pointer is stale if there isn't enough room. In that case, the reference will be pointing to deallocated memory. The borrowing rules prevent programs. Okay, so they're telling us how the Rust compiler works internally because it detects this kind of thing and interesting. Iterating over the values in a vector. Each access each element in the vector in turn. We would iterate through all the elements rather than use indices. Listing 8.7 shows how to use a for loop to get immutable references to each element. Immutable, just plain references then. For I in a reference to V, I can also do the mutable thing and change them in place. We saw this in the other example. I guess let me run this just for... Okay, and then I can make these mutable and I'll C plus, whoops. Oh, I forgot to print. Well, we can do the print after we do this. Okay, also I kind of abused the scope here. I guess this reference goes out of scope once the for ends, because otherwise I could not have had... No, I can't have an immutable reference after a mutable one. Yeah, they must go. So I bet you I can probably duplicate this, right? So I can have another reference. Yes, I can. Okay. And I can even print in the middle. Yeah, these all go out of scope. They must. All right. To change, we have to use the star dereference. Oh, I didn't even notice that. Holy shit. Okay, so I guess we can do it the brute way. How about this? No, but what was it? V iter mute. No, enum mute. And then I can say V of I. No. I can say ln plus 50. I don't need the enumerate. Of course, I'll just do iter mute. So I can do this, right? Or I need the dereference here. Binary assignment can only be applied to mute integer. Yes, I need the dereference here. Interesting. Okay, so same thing. Definitely like this notation better. Although yeah. Everything returns references anyways. Okay, to change the value, we have to dereference. Iterating over a vector is safe because of the borrow checkers rules. If we attempted to insert or remove items, so the reference, the vector that the for loop holds prevents it's okay. So this makes sense. If I try to do like v dot push 5, this should be a quick compiler error. Yeah, cannot borrow v as mutable because in this scope it's already borrowed. And probably not even the other way works, right? If I do a non-mutable iteration, cannot borrow because it also borrow as immutable. Okay, good. Very good. So it's not even a double immutability issue. It's like a mutable borrow cannot occur after, inside the same scope after an immutable borrow occurs. Okay, makes sense. Let me take these off for now because there's nobody here. Using an enum. Vectors can only store... Okay, this is getting a bit too advanced, probably. Let's read it. Okay. Vectors can only store values at the same time. This can be inconvenient. There are definitely use cases, okay, for needing to store a list of items of different types. Fortunately, the variance of an enum... Okay, so enums are fake types, basically. I mean, they're meta types, right? So we need one type to represent elements. We can define and use an enum. For example, say we want to get values from a row. Okay, so it could either be, I guess these are the names, right? It could be banana, apple, whatever. These are the types. So if I run this, this probably works. I guess I get some weird ass errors. I can print this. Let's see, does it have the pretty print? It does not. Hey, thanks for joining. Thanks for stopping by. If I try to print the debug thing, I should see a bunch of stuff. Oh my god. Okay, never mind. This is way too advanced. Never mind. So an enum is a container. No, this is just no, you didn't miss much. I just started like half hour ago. No, you're right in time. I'm just getting warmed up. Thanks for stopping by again. Yeah, this is gonna be fun. Yeah, I basically just like, it's literally where I left off. I just started. The only reason is because, so I did the quiz again, which was too easy. And then the next section in Rustlings was Vex. And they even say here in the README, let me put the Twitch chat on so the YouTube knows what we're talking about. They even say in the README, yeah, it's kind of out of order, because if I go to the book, it's like chapter 8. So then I messed around with vectors a bit. The thing is, in the book, this is after borrow checking. So I kind of started to understand borrow checking. Specifically, this is the one I like the most. I spent a bit of time, but let me see if I got it again. So this doesn't build, because you take you build a vector, okay, with... Now the compiler doesn't know it's length 5. It's not smart enough, so it has dynamic length. Then you take a reference, immutable reference to first element, and then you touch the vector, and then you can no longer use that element. But then if I use it in this order, this works exactly fine. Yeah, because I guess the compiler is smart enough to keep track of these references that I mutated after. Well, I no longer use it after I mutated. So this was pretty nice to understand, because they don't tell you how to fix this in the book. All right, iterating is pretty easy. We saw this. Yeah, this one is already a bit too confusing. Although not really. Okay, we'll get to it. If you don't know what exhaustive said now, we'll discuss some of the most common ways. Be sure to review the API documentation. Like any other struct, this is already a bit too advanced. The vector is freed when it goes out of scope. Okay. The borrow checker ensures that any reference... Yes, okay, so now, okay, you know what? Let's go back to Rustlings now, yeah. Let me see. So dropping a vector drops its elements. Like any other struct, vector is freed. Okay, this is probably... I mean, this example is kind of vacuous because there's nothing referring to these. All right. So now in Rustlings, it says, yeah, so this is what you say. So in Rust and other programming languages, they'd be called arrays, but Rust operates an array in Rust is stored on the stack. So it's known at compile time, which is exactly we saw the bracket notation last time, right? Where you do bracket, semicolon, length. Type, semicolon, length. So this is perfectly known. This is an array, right? If I remember. Yes, it is, if I remember correctly, yes. Whereas vector is a vec stored on the heap where the restrictions don't apply. So it's dynamic sized. Oh yeah, the other thing they taught me was there's a match unpacking with some and none. So if you take, where the heck was it? Oh, it was here. If I use a get, so I can get the raw reference through some index, and then, oh, this is actually a good one to try again. Hang on, let me see. So if I try to get the 12 element, this is a runtime panic. The compiler is not smart enough to know it, right? Because it can't even infer, although you would think so because these are 5 in plain text here, but I guess it doesn't work that way. Yes, there's get mute, yeah. But the other thing is, this was the first time I saw this, but I can kind of guess what it means because it's an option and I can unpack it and I can continue my program. So if I try to get 25 here, which is not an index, yeah, I can still continue the program. And I also know, I guess this is now, no, this is not special. I don't know how to specialize this yet. But probably I'll learn later. Or I guess we always have to match on it. Like in the sense that, is there a let third equals third? No, because there can't be, because it doesn't know what type it is, right? So I would not know how to annotate this. So I would still be stuck with an option, which puts me in a circle. Yeah, so I can't specialize this at compile time, right? I cannot infer its type. Yeah, this makes sense. Like, there's no way. I just have to match on it every time I want to use it from this point onwards, right? I'm guessing in the program. Like, maybe I want to use it later in some other logic. Yeah, I just need to match every time. It's not like I can match once and then I can store its value into something known. I see, there's a matches macro. Interesting. But it is a runtime cost though if I have to match it every time, I'm guessing. So it actually runs, right? Or the compiler doesn't optimize it away. Like, it's actually branching. All right. Okay, so now let me see what they want with the exercise. I'm guessing these are gonna be pretty easy though. Maybe not. Okay, an array is also just an array without vec. Okay, so okay, create a vector. Okay, this one's easy because it's just let v. It's just a, yeah, matches usually, but there's exists something called brand. Yeah. Oh, okay. Yeah. So that's I should know that because I work at Intel, by the way. Definitely know a lot about CPUs, but I was never a hardware guy, so maybe not too much. So this will be a vec of i32s. It's exactly the same notation. I don't even need to annotate it because i32 is the default type, but I'm just gonna do it because I like it. Okay. Well, what the heck? It's only 2 exercises. Oh, let's try that one then. Let's see. So you're saying there is a let v, which is also I32. 2vec method for what? For the array, like a2vec? Yes, there is a method on the array called 2vec. Okay, for arrays and slices. Yep. Okay, that's good to know. So there's a... Okay, so I would have found this if I had studied the array. Oh, I think we looked at this last time, right? Because there's like 5 million methods. Yeah, it has like everything you want here, probably. Yeah. Yep. I just have to memorize these eventually, yeah, as slice. Oh, yeah, we saw this exactly last time with the splits and all the crazy stuff, transpositions. Okay. Next one. And I guess it ends abruptly. But then you're just in time because I want to do this. Today was the plan to do the structs though. Like this is kind of just a warm-up, I'm guessing. Vec2. I probably overthought the vectors, but at least I know more now. So what the heck? To vec as it is, Rust will take ownership. I'll take ownership of the array, if I read that correctly. Okay. Okay, good. No, this is helpful because I need to get used to the language. Yeah, so take, okay. Take ownership. So then what you're saying is, but the arrays are, oh, no. So what you're saying is if I do let's do it this way. So if this had been a mutable array. Oh, it doesn't. Okay, I was gonna, so, okay, so that's fine. So then what you're saying is, how the heck do I edit this though? Like, A0 is 100? Sorry, there's a thing here. So list, I can reset the exercise, okay. Oh God, what did I do? Okay, I'm here. Continue at. Okay, sorry. So let's go back. So if I do a mutable and I do let v is a to vec, was it? Yes, okay. And then if I try to mutate, no, but the problem is I don't know how to mutate. Is this a syntax for mutating? It is. Yes, it is. Okay, so it worked though. Okay, so you're right. It doesn't take ownership because I can mutate this. I mean, the test fails because of... well, of course the test fails because it checks if they're all equal, but it doesn't panic. All right. I got a warning. Doesn't need to be mutable. Sure, whatever. Okay, I don't know what the heck I did. I press... Aha, into vec. Okay, so then what you're saying is if I go into vec and I do, actually let me do this because it's easier in the playground. So this should not compile then, right? There is no method into vec. Or maybe I don't know how to use it. Rust into vec. Oh no, that's something else. That's for a box. Okay. Yeah, well, there is, but it's for a box. Okay, it's a bit more advanced then. Not for arrays. Okay, we'll get to that. We'll get to that. Okay. Let me go back to yeah, it's for a box, which I vaguely know what it is, but that's a bit more complicated probably. Although I can see why, yeah, there's probably way more mutability. Borrow checking issues there. All right, so what does it want me to do here? So a new vector on the heap, which I guess also is not type annotated. So whichever element goes first gets to claim the type. Sure. Multiply each element in the input size by 2 and push it to the output vector. So we can just do output dot push. Oh, this is so easy. 2 times element. Yeah, because they already did the iterator for me. And this is an iterator through, it's not through a vec, it's through an array. Or is it, this is a slice, right? This is a reference. Oh, there's more stuff for me to do. Okay. So I put to do. Okay. An example of collecting a vector after mapping. Damn, I don't know. This is called a closure, right? I can barely read this. So like it's a function applied to each element. It returns element plus 1. Yeah. And the map applies it to each. So map means apply this closure to each element. What the heck is iter? What is input.iter? It converts it to an iterable, and then for each element in the iterable, apply this function to each element, and then collect it back into a vector. Okay. And I guess collect returns the vec i32, and we're supposed to know that. Okay, fine. Now what do I need to do here? Here we also want to multiply. Oh, I see. Collect collects it. Oh my god, okay. Interesting. So it's actually... So it could have been... Oh, an array. I could have returned a reference, a slice too? So I could have returned a slice if I wanted, right? If I change the output type to also be a slice, this will magically return a slice. Interesting. Interesting. All right, so let's see what else. We also want to multiply each. Okay, so it's just the same thing. So I produce an iterator from the input. Borrow check will probably stop you since you're referencing dropped data. Which one would be the drop data? The input that gets dropped outside of the scope of the function. I can't turn it, I can't pass it back to the outside world, right? Because this reference gets dropped when this function exits. Okay, I think I get it. Yeah, slowly, but okay. All right, it kind of makes sense. And this is all without reading borrow checking, yeah. But it makes sense. Pretty good. All right, so... Okay, so this is the same example except they split a new line. So I just need to... I mean, this has nothing to do with vectors then. So what the heck? They just want me to write the function. We also want to multiply each element in this input size by 2. But with iterator mapping, so I'm pushing it out. So just 2 times element. That's it? Okay, kind of lame. I guess this is more to teach you about the... Yes, each of the items in the iter is a reference, right? Like the first one is a reference to the first one, the second one a reference to the second one. I think we saw that last time. Sounds familiar. Okay, we're done with this. Next. Move semantics. What the heck is this? Is this still on vectors? Oh, this looks pretty complicated. These exercises are adapted from some random guy's Rust tutorial. For this section, oh my god, what is ownership? I think it's starting. Okay, it is starting. Holy shit. Okay, well, I guess they want you to do this before the structs. Okay, fine. So let's do this one then. So, what is ownership? Yeah. All right, this is gonna take a while. I think it's gonna be fun though. Although I kind of vaguely have some ideas. So instead of rules that govern how, okay, this is probably too high level. However, all programs have to manage the way they use the computer's memory. Sure. Some languages have garbage collection. We know Rust is famous for not having that. Okay. The programmer must explicitly allocate them free. Rust uses the third approach. Oh, so there's three approaches. Garbage collection, explicitly allocate and free, which is C basically. All right, C does not garbage collect for you. Rust uses the third approach. Memory is managed through a system of ownership with a set of rules that are compiled. If any of the rules are violated, another feature is ownership. But yeah, C is garbage collected. Oh shit, I should know that. Wait, C is not? So what is the programming language where you explicitly allocate and free? Like even lower level than C then? Or... No, it isn't, right? No. Yeah, C is the lowest level. Like you must explicitly do yourself anything you want. It doesn't free stuff for you, right? There's no drop or garbage collector, stuff like that. I think C++ may have a garbage collector. Yeah. Okay, so Rust is different. None of the features of ownership will slow down your program. Okay, so this I kind of knew. Yes, so borrow checking is purely compile time. Because ownership is a new concept, it doesn't. The good news is that the more experienced you become, okay, which kind of we're starting to notice a bit, rules of ownership, the easier to find naturally developed state and just keep at it. When you understand ownership, you have a solid foundation. In this chapter, your own ownership, we're working through some examples. Oh, Go, I see. Okay, I don't have, I see, interesting. Go is garbage collected. In this chapter, you learn ownership by working through some examples that focus on accommodators such as strings, stack, and the heap. In a system programming like Rust, whatever the values on the stack or the heap affects how language behaves and what you have to make. Parts of ownership will be described in relation to the stack and the heap later. Both the stack are parts of memory available, but they are structured in different ways. The stack... Yeah, I mean... stack stores value in the order, gets them, and removes the values in episode order. For the last in, think of a stack of plates. The way I know it is that stack is compile time and heap is runtime, basically. When you add more plates, you put them on top of the pile. Okay, these are just the basic concepts. I guess this is an implication because all data stored on the stack must have a known fixed size. That's why you put data on it at only data that you know at compile time. That data with an unknown size at compile time must be stored on the heap. Yeah. Heap is less organized. You request a certain amount of space. The memory allocator finds blah, 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 marks that being returns a pointer. But there are also stack pointers. Or Rust doesn't have that at all then? Because I know C has stack pointers. No, it must have them. Like function pointers are stack pointers, right? Even in Rust. like a pointer to something in the stack, like a reference to a function, for example. Oh, Rust has no function pointers? Oh, I see. Okay, so it doesn't have any. So anytime we say pointer in Rust, we talk about pointing to something on the heap. This process is called allocating on the heap versus allocating. Because the pointer to a heap is known fixed size, you can store the pointer on the stack. But when you want the actual, okay, obviously, think of being seated. Pushing to the stack is faster than allocating on the heap. Sure. Okay, yeah, because this is compile time versus compared to looking at runtime. Accessing data is generally slower. Okay, when your code calls a function, the values passed into the function, they get pushed onto the stack. Okay, so this is just a scope. Keeping track of what parts of code are using what data on the heap. Well, in C, it's just the function, the symbol name, right? It's a function pointer, so you can just based on the signature, you can, yes, yeah, exactly, like, but I don't know how that is in, I don't have no idea how that would be in Rust. I guess it's a reference to the function name or something, or is it the function name as a type, or it has to be something like that. I don't know what the type of that would be, but we'll probably get there, but that's probably on the advanced side. Oh, it's FN. Oh, I see. So that's basically a giant type, right? Like FN, arrow, I see. Functions are of type FN. Okay. I see. Interesting. So the whole signature is a type. Okay. Interesting. Interesting. Okay, but knowing that the main purpose. Okay. First, let's take a look at ownership rules. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. I'm kind of a bit confused here already. So each value, I think I missed some of the more basic names here. So what is a value? Okay, so I need to read this again. So but then, so if I do, okay, I feel like I'm missing something here. Hang on, because I'm a bit confused. What the heck is? No, but we went through this. Okay, maybe I'm overcomplicating it. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. Now we're past basic. We won't include all the FN main. Okay. Our examples will be a bit more concise. A scope. Okay, so hang on. They explained it here actually. Okay, so finally we get to know what a scope is. So a scope is the range within a program for which an item is valid. Take the following variable. S is the variable. It refers to a string literal where the value of the string is hardcoded. Okay, I see. So variable value. Okay, the variable is valid from a point which is declared until the end of the current scope. Okay, so this is a scope. Okay, we know this. When S comes into scope, it is valid. By owner extension, there can only be one reference that can mutate the value. When S, if it remains valid until, okay, at this point, the relationship between scopes are rather similar than another. String type. To illustrate the rules of ownership, we need that it is more complex. The types covered previously are of a known size, can be stored on the stack and popped off the stack when the scope is over, and can be quickly and trivially copied. Okay, so string is like basically a vec of chars then, right? Because it's on the heap. We'll concentrate our parts of string that relate to ownership. These aspects of Plato. So we already see string literals or string values. String literals are immutable, of course. Yeah, I can't mutate this. I need a proper string. Oh, box of chars. Okay. Yeah, yeah. Essentially, okay. One reason is every string can be valued. For example, what if I want to take the user input and store it? Rust has the string type. Oh wait, we read this last time though. Yeah, box, but so is the vec, so I still need to understand there's probably a difference between box and I think I vaguely remember something. It's, yeah, it has to do with how it stores the type, right? Information or something. Okay, we went through this last time. No, so as string from hello from. This kind of string can be mutated, so I can push world. Okay. Why can string be mutated, but literals cannot? In the case of a string literal, we know the... Okay, so because it's on the stack, right? Obviously. Yeah, we can't put a blob with the string type in order... With the string type... In order to support a mutable, we need to allocate an amount of memory on the heap, of course. So, okay, this means the memory must be requested. We need a way of returning this memory to the allocator. Okay, the first part is non-biased. When we call string from, its implementation requests the memory. Right, because it knows how much to ask. However, the second part, in languages, the garbage collector keeps track of and cleans up memory. In most languages without, it's our responsibility to identify where memory is no longer being used and to call code. Doing this correctly as this store... Okay. I see. We need to pair exactly. Rust takes a different path. The memory is automatically returned once the variable goes out that owns it goes out of scope. I see. So the value is hello here. The variable is s, and it owns the value hello, which is now on the heap. So, okay, this kind of answers my question, because if I have two of these, okay, so if I have let s1 and s2, these are two different values now, each stored in two different variables, and they both get allocated different memory on the heap. And once these go, oh, sorry, where was I? Okay, here. Okay, so then once it goes out of scope, then the value gets dropped. When a variable goes out of scope, Rust calls a special function. This function is called drop, and it's where the author of string can put the code to return the memory. Oh wait, so you can actually, this is code, it's not automatically generated code at compile time, it's actually Rust code 2 that does the drop. So I can look at the drop method of string, for example. Rust. Yeah, dropping is a trait. So the Rust standard library has this implemented, right, for string. I don't know where to find its code, but probably here. And it has a trait. It doesn't have a drop. I guess it's why doesn't it have a drop? Huh. Is it too fundamental? Like it's actually not. It's like burned in the. Okay, standard ops drop. Okay, all right. Let me not go too deep, but there's a natural point. Okay, where's the author? In C++, the allocating is for a resource. Okay. The parent has a profound way on the impact. It may seem simple right now. Behavior can be unexpected and more complicated. We're going to have multiple variables use the data we've allocated on the heap. So gotta be very careful if we have multiple variables referring to the same data, because if one of them goes out of scope, the underlying value gets dropped. So then that code should not compile then, right? Because the compiler should be smart enough to track that, hey, you have 5 references to this, but you just dropped, or one of them went out of scope. So you need to make them all go out of scope, or I guess the next time you try to access it, or you can't access it from this point onwards, right? You can't read from it, you can't write, you can't do anything with those references. Let's explore some of those situations now. Okay, okay, here it is, exactly. So multiple variables, okay, this is exactly what I mean then, yeah. So let x equals 5 and y equals x. Bind the value, then make a copy. Yeah, so here they show us the naive example. So I guess for integers, it's magically a copy, but not for strings. Because we might assume, but the second line will make a copy of the value, but it isn't quite what happens. Take a look at figure 1 to understand. A string is made out of 3 parts, showing a pointer to the memory. Yeah, scalars implement the copy, but I see. Yeah, because the size is not compile time, but not for string. It has a pointer, a length, and a capacity. Okay, this is exactly like a vec then, but yeah, or a box probably. This group of data stored on a stack. But the problem is why? I don't know the length. So I do know the length. Oh no, because it's currently using. So the length is how much memory the contents are currently using. The capacity is the total amount has received. I can ignore the capacity. When we assign S1 to S2, the string data is copied, meaning we copy the pointer. Okay, so we copy the pointer, the length, and the capacity. We do not copy the data. Okay, so I see. So it's just a pointer copy. Yeah, so it's not like figure. We don't actually duplicate the underlying. Okay, so this makes sense. So now if this data goes out of, if something frees this data up, I can never use. Yeah, we copy the pointer at that moment. So then when I act, it's true for either of them, right? If I act either on S1 or on S2, the other one is not synchronized anymore. Yeah, so as actually anytime I touch the underlying value, because that's what they call these, then it's all over. Like I cannot rely on the other references anymore. So then the compiler is gonna yell. Earlier we said that, yep, exactly. So, but I can't even read from the other one though. It's not even mutable, right? Like if S1 is mutable and S2 is immutable, if I first create S2 and then I touch S1, I can't even read again, or I can. No, I can't because the length is wrong, right? Like if I pop some data from through S1 through the mutable reference, I can't even read it through S2, which is an immutable reference. We said that when a variable goes out of scope, Rust.max goes to drop function, cleans up the memory. But figure for 4.2 shows data. This is a problem. When S2 and S1 go out of scope, they will both... Oh, wait, he's talking about something else here, though. Okay, it's more basic. When they both go out of scope... Oh, there's another type of error. It's a double free error. I see. Rust installs missing. Okay. So double free, freeing memory twice. Yeah, to ensure memory safety after the line. Oh, so actually Rust does something else. Like even after the line S2, S1. Okay, so you're locked out of S1 forever. You cannot even read it anymore, right? So you can't use it in any way. Yeah. Okay, so it's just an invalid reference forever now. Okay. If you've heard the terms shallow copy and deep copy, the concept of copying the pointer, that's a shallow copy, yes. Because Rust also invalidates the first. Because Rust invalidates the first variable, instead of being called a shallow copy, it's known as a move. In this example, we would say that S1 was moved into S2. Yes, it's grayed out, so only S2 is valid. When it goes out of scope, it alone will free the memory, and we're done. So basically, the compiler marks this as dead. Do not free it when it goes out of scope. Okay. In addition, there's a design choice. Rust will never automatically create deep copies of your data. Therefore, any automatic copying, I see. So all the, basically it's saying that the clone trait is always, no, that's something else. So clone is deep copy probably, right? But any automatic, okay, so any equality symbol is always a shallow copy, basically, or it never copies data. Like any variable assignment like this. It's never a deep copy. This is pretty Pythonic. Because this is how Python lists work too, I guess. They don't deep copy the data. The inverse of this, scope and assignment. The inverse of this is true for the relationship between scoping orange memory being freed by the drop function. When you assign a completely new value to an existing variable, Rust will call drop and free the original value's memory immediately. Consider this code, for example. String we immediately create a new string with the value ahoy and assign it to us. At this point, nothing is referring to the original value on the heap of course. Okay, so he's talking about the value here. So the hello was dropped forever, like it doesn't, yeah. Yeah, like this is, what the heck? This is wrong or? Wait, so. There's no difference if I put the. Does it? Or it seems like it's implicit, right? Or. I know we saw it last time, like it should be let, but it seems like it works. I'm surprised it works without let. Yeah. Oh, this is not shadowing. Oh, right. Wait. This is assignment, right? Oh, this is assignment to a variable. It's not shadowing. You're right. Yeah. Sorry. Oh, I see. So it's reassigned. But then if I do this, the drop is still true, right? The hello is still dropped, even with shadowing. It must be, yeah. Okay. Actually, so why would you not do this then? What is there any difference here? If you. Okay, so this example is trivial. Yeah, there's no. I'm guessing there's more advanced cases where. Like if it's the same type, is there any difference between reassignment and shadowing then? I get if you change the type, then yeah, like if it's I32 is 4, then you need the. Yeah, okay, so it is only the type. Yep, okay. So if it's the same type, there's no difference. Okay, that makes sense. Yeah, shadowing is just to change types. Yeah, which is basically completely new variable. Yeah. Okay. Variables and data variable clone. If we do want to deeply copy the heap data, not just the stack, we can use a command called clone. Okay, so clone is the hard copy. Okay, so now you have two strings. I guess string references is the right term, and they both point to separate data, so now you can do weird things to one of them and still use the other one. Like for example, now I can do what it didn't work. I'm pretty sure now I can do. So what were they trying to do earlier that wasn't working? It was oh yeah, like printing. Oh well, I guess they do it here. Yeah, so you can print okay, I see. So I have to be extremely careful. Should never assign references. There's another wrinkle. The code using. Okay, so integers. Integers have a known. So yeah, we talked about this earlier. So they have a known size of compile time or certain turn stack. Copies are quick to make. Sure, that means there's no reason we don't prevent X from invalid. There's no difference between deep, so calling clone. Rust has a special notation called the copy trait that are stored on the stack as integers are. If a type implements the copy trait, variables that use it do not move but are trivially copied, making them still valid. Rust won't let us annotate a type with copy if the type has or any of its parts has implemented the drop trait. If the type needs something special, interesting. So what types implement the copy trait? All basic data types. And tuples if they are recursive. Okay. All right, now we get to the something more interesting. The mechanics of passing a value to a function are similar to those when assigning a value to a variable. Passing a variable to a function, move or copy. Interesting. So listing has also some annotations showing variables. So I take a string. S's value moves into the function and is no longer valid here. Yeah, nested structures, yeah. So as long as it's copied recursively, it can be copied. Yeah, that makes sense. Whoa, hang on. What's happening here? So basically, what this is saying is that if I... So I can't use S anymore because it got dropped? Yes, I think that's what this means. This is pretty bad then, right? So I can no longer do the string, or I can't do S anymore. Yep, okay. So I pass it to a function. I see. So the mistake here is I should have passed a reference, not the actual string, because if I... Yeah, and so I passed the real object, it took ownership. It's not a borrowing of ownership. It's not a borrow, right? It actually takes ownership, and then once it exits, it drops the real data behind it, and it's gone. Like, it's toast. So I'm assuming the right fix is to... I should have passed a maybe not, actually. I don't know what the... Is it a reference then? And then yeah, it won't take ownership for... Okay, so then what that means is I can print X here, right? Because it doesn't, because yeah, it's cheap to copy. So then it copies, it just copies the scalar data or whatever is copyable. So then this one works. If I, of course, comment this one, I would expect this to work. Yep, it works. Yeah. So takes ownership, makes copy. Yeah, so that's the real fix, which we'll probably learn about in references, is I should have passed a reference and then that reference gets dropped, but nothing happens to the... I don't know the syntax. So is it like reference to string and that's it? Yep, it is. There we go. So it's just a reference, and now and mutable works too, because this is runtime. So if this would have mutated, I would have printed the new value here, right? If this would have been takes ownership and mutates, I think. Okay, that sounds about right. Yeah, okay. If we try to use S... Okay, so we just discovered this by ourselves. Try adding... Okay, we literally just did this. Good. Good. Return values in scope. Returning values... Oh shit. Returning values can also transfer ownership back to the program? Ah, so this is the other... Okay. But when you take ownership, you can't... But you can return it. This is what they're going to tell us now. All right? I could have returned that back to the... outside of the scope without dropping it. Or what's happening here? Yep, takes and gives back. Yep, okay. So there's another fix here where I can just say... I print it, but then I give it back to you with string. And I say some string, and I have to assign it to, I guess. Cannot assign twice. Oh, because I made it immutable. I guess I can always shadow it then. Yeah, shadowing works here. But I accidentally made this. I guess if I put a mute here, it magically works. Yeah. I don't understand why does it want mutable here? Because this function has no idea. Okay, I see. Because the compiler can't infer if this actually changes or not. So then it's being conservative and assuming that. Maybe. Interesting. All right. Yeah. So this is what we saw. So gives ownership. Take ownership has no idea of the S variable. I see. So the compiler, yeah, the compiler doesn't know if this thing doesn't. But why? Because if this is. Oh, yeah, because it could be. This function could do stuff in place to it, like S push A, right? But the compiler doesn't know that. Okay. I mean, some string, not S. But there's also a gives ownership, which starts from nothing. Oh, interesting. So you can create the string inside something and you can pass ownership on the outside directly from inside. Ah, okay, I see. I think you're right. So this function could have just create. Oh, okay, I got you. Yes. So it could have made something completely new, right? So it could have said let completely new is string from whatever, and could just return completely new. And now, but isn't this shadowing then? I need a let here. Wait, so mute? How come I can get away with a mute here then? I guess this means that, because you know why I don't get it? Because I'm not really mutating this data, right? So this feels like bad programming, right? Like shadowing is the right answer here, probably. Or is it mute? This one definitely makes sense to me, but the mute, because I'm not actually mutating anything. Oh, I see. It's not. Oh my God, I think you're right. I'm so dumb. So mute is not the underlying data. It's the reference itself that's mutable. So then if, yeah, okay. So then the compiler wants you to do it like this because it completely changes here, basically. Okay, so yeah. Okay, so for strings, okay, I think I'm confusing things. Yeah, so mute is not, it doesn't mean that it's mute, it's the underlying data. Because that's implied from a string anyways. Oh, yeah, you're right. Because I can do this. I can do S push A without mutability. And this is fine. Yes, a char. Very good. Ah, no, see, it wants a mutable here. Interesting. I guess when you do the push, it mutates the S2, right? Because you're changing the metadata in S2. The length becomes 6 now. So you still need mutability here. Yeah, that makes sense. Yeah, okay, so any change in the metadata that we saw, like either the pointer, the length, or even the allocated size, which means any type of change on the underlying data, yeah, you need mute. Okay. Yeah, this makes sense why this doesn't work. Like even this basic one, right? You can't do this because when you push the length, because S is a fat pointer, right? So it has a length too. So then it has to be mutable. S itself. Yes, and the length goes from 5. Yeah, exactly. It goes from 5 to 6. So it's the fat pointer part, right? So it still has to be mutable. Yeah. Yep. Yeah. All right. Good. Good. Very good. So, okay. So we can also create a variable, which we also just did ourselves earlier, by the way. We made this function return a pass ownership from the inside out. So it's not only from the outside in. You can also pass it purely. And then you can a string and takes and gives back. We saw this too. Yep, we discovered all this by ourselves, which is good. The ownership of variables, assign a value to another variable, moves it. When a variable that includes data on the heap goes out the scope, taking ownership and return is a bit tedious. I agree. What if we want to let a function use a value, but not take ownership? It's quite annoying that anything we pass in addition to. Okay, so now they're going into references. Yeah, exactly. Yeah, that's exactly a reference. So what should I do? Let me see, because we went kind of, we're pretty advanced now. Let me see, what the heck does this, let me go back to Rust links, because I have a feeling this is going to be... Oh, no, they want you to read reference and borrowing. Okay, fine. We're reading the reference and borrowing too. Oh my god. Okay. Another big one now. Because we understand ownership, we're at the borrowing. Using a value. Yep. Okay, so the issue with the tuple codes are returned. Yeah, so the tuple code is obviously horrible. So we can use the string, but because the string was moved into calc, instead we can provide a reference to the string value. A reference is like a pointer in that it's an address that we can follow to access the data owned by some other variable. So when the reference goes out of scope, because it doesn't own the data doesn't go out of scope, which is very good for us. Unlike a pointer, a reference is guaranteed to point to a valid value of a particular type for the life of that reference. And when they say guaranteed, they mean compile time, right? So there's no way to get it wrong in the code. Here is how you would define and use a calculate length function that has a reference to an object, right? Because there's no reason to pass this out and in and out. That would be insane, of course. Let's see, can we mess with this? Length of hello is 5. I guess I can also push, so if I do S1, by life they just mean for the local scope. Yes, so in this case for S1 it's the scope of the whole program. I can also push an S something and I can make this mutable. Okay, the length of hello is 6. What if I push after I calculate the length? I have a feeling this is gonna be a problem because... So I calculate the length using that reference, but if I push after... This one seems nasty. Did I just desynchronize things? I did. Okay. Yeah, so but this is a this is a complete desynchronization now, right? Yeah, exact. No, because I was well, I was hoping the compiler prevents against this, but it doesn't, right? So now I gotta be careful here, because if I calculate length, it is, but yeah. So I have to be careful that anything you compute through a reference is basically it's like a frozen state, right? Yeah. Okay. And I can also do this again. I can take another reference now to synchronize. Yeah, it's just it's a logical bug. Yeah. So now I'll get the right answer. Yes. Okay. So I think what oh yeah, hey Nate, thanks for joining. I think what Nate is hinting at is probably there's some smarter construct in Rust that would actually be a permanent reference to the length, although that sounds kind of fishy. I can always just compute it. Is that a thing? Am I guessing that right? So is there... No, that can't be right? Like, I can't permanently attach something that gives me the... No. That's not how Rust... I think we talked about this last time too, yeah. So this is just business logic. You can return a reference and it's a normal reference. Yeah, that's what I mean. Okay, yeah, so of course, that's too naive. Yes, we can't have a reactive value in compiled languages. Yeah, that would be insane, right? Like something that magically keeps track of the... Right? Like if I do this, something that would magically become 6. That is absolutely not a thing. And that makes sense to me, yeah. I think we talked about this last time too, yeah. I gotta get used to it, yeah, because... I guess that would be called a method, a trait, right? You would implement a trait on... Well, it is a trait already. It's okay. So yeah, right. I think I'm way overcomplicating this because the answer is probably just say s1 dot length, for example. Push. Yeah, there we go. We fixed it, right? So yes, I know. Yeah, okay. I'm overcomplicating, but this is good. Okay. So first notice. Okay, let's go back to this. All the tuple code in the variable declaration, the function variable. Okay, so yeah. Second, we pass reference s1, and definition we take string. These ampersands are okay. They allow you to refer some of the. Right. So it's a pointer to a pointer in this case because the string itself is a pointer. Dereferencing I have not seen that much so far. I actually don't, but it kind of makes sense, but maybe not. Okay, we'll get to that later. S1 calculating the S1 syntax occurs where first the value because reference the value points to it. Likewise the signature of the function. Okay, S is reference. Let's add some explanatory annotations. S, the reference goes up because S does not have ownership. Okay, the string is not dropped. Good. The scope in which the variable S is valid, but the value pointed by reference is not dropped because S doesn't have functions references. We won't need to return the values in order to get back. Okay. We call the action of creating a reference borrowing. If a person owes you something, you can borrow it from them. When you're done, you have to give it back. You don't own it. What happens if we modify... So this is because we have an immutable reference. Yeah, so I cannot push to this. Okay, the compiler even gives you a hint. It should have been a mutable reference. Just as variables are immutable, so are references. We're not allowed to modify something we have a reference to. Mutable references. We can fix the code, but let's modify borrow variable just to use a mutable reference. Okay, so this works. And if I print S before and after, I'll probably see exactly what I think I'll see. Yep, it's the, so it actually mutates the data. Sorry, the value, I should say. We create a mutable reference where we call the change function and update the function signature to accept a mutable reference. Change function, mutable reference that one big. If you have a mutable reference, you can have no other references to that value. Not even an immutable one. So not only does this fail, but also this fails. But also, if I use only one at a time, okay, I kind of guessed this would work. I think I've seen this before. So I think what they mean to say here is a bit more subtle. So this works with mute, I'll bet you too, right? Yeah, it does. It has to do with when you use them, not when it's... There's some magic happening here. We cannot borrow more than once at a time. The first mutable borrow must oh, I see what's happening. So the compiler is inferring the lifetimes here, and it's magically dropping this R1 because it knows it's only used here. So, well, yes, it's dropping the reference, right? I said that right, I think. Well, not dropping. Making it go out of scope. It's like scoping this somehow, magically, for us. I think so, right? Because I'll tell you why. I cannot do... I definitely can't do this now. Obviously. Yeah. But I can do this as many times as I want to. So as long as they're not interleaved. The first one occurred, but between the creation, yeah, okay. So it has to do with some causality here. We try to create restriction preventing use the same data loss for mutation, but in a very controlled fashion. It's something that newer stations struggle with because most languages that you mutate whenever. Okay, so there is that causality, like I guessed, yeah. The benefit of this resistant arrest can prevent data races, exactly. So there's no way to erase. Data race, to erase condition happens when two or more pointers access the same data at the same time. At least one of the pointers being used to write to the data. There's no mechanism being used to synchronize access to the data. Data races cause undefined behavior and can be difficult to diagnose and fix when you're trying to track them down at runtime. Rust, okay, obviously. I think so. I get it though. Like this makes sense to me that there's some implicit scoping happening here. There's something even trickier here. So wait a second. So oh, yeah, because the rule is when you have a mutable reference, you can't have others. But I can have 15,000 immutable references and do weird things with them at the same time. Yeah, so this is all fair game here. It's just that when I have a mutable... Yep. Well, this is what I was contesting earlier. You can't have two mutables. You can have three mutables, but you can't... You have to split the prints here, right? Like, you only have to use... So this is gonna work, right? If I just do R2. But I guess there is a time component here that the compiler magically infers, which is not that hard now that I think about it. This is pretty easy to parse if I was a compiler. Because it's always last one wins, right? Yeah, it must be perfectly separatable in blocks. Okay. We also cannot have a mutable reference while having the mutable one to the same value. Use a mutable reference. Users of an immutable do not expect the value to suddenly change out from under them. However, multiple immutable, because no one... Okay, obviously. A reference is scope. This explains... Okay, never mind. So yeah, it is clearly defined. Yep, exactly. So... Okay, so there is implicit scoping then. Okay, actually it's pretty much explicit based on what this says. So a reference scope starts from where it's introduced and continues through the last time it's used. Okay, so we discovered the fix ahead of time. The scopes end after the print line. These scopes don't overlap, so this code is allowed. The compiler can tell that, yeah, okay, good. Even though borrowing errors may be frustrating at times, remember that it's the Rust compiler pointing out a potential bug early and showing you exactly, okay. What the heck is a dangling reference? In languages with pointers, it's easy to erroneously create a dangling pointer. References location memory that may have been given to someone else. Oh, these are impossible in Rust then, right? There's no way. The compiler guarantees there will never be dangling reference. If you ever reference to some data, the compiler will ensure the data will not go out of scope before the reference to the data does. Let's try to create a dangling reference. Yeah, so here S would have been dropped out of scope. I would have gotten this reference to S, which is a reference to S, but then the underlying value got dropped, so this leads nowhere eventually, but then it doesn't let you compile, which makes sense. The compiler message is, oh my god, lifetimes. Okay, this one I've heard about. I don't know lifetimes what they are, but it's fine. Returns the reference to a string, blah, blah, blah. Okay. Yep, there we go. So S goes out of scope. Yeah, so the reference will point to... I guess what I didn't get from the earlier section is when S goes out of scope, the data gets deleted. The fat pointer gets deleted too, or is that... No, that's on the stack. That it gets popped off the stack, right? So it's gone too. So like the whole chain breaks here, right? Because S1, the data is obviously gone. S1 is also gone, so this would be completely dangling. Oh, the pointer doesn't get deleted. Oh, it doesn't? It doesn't get popped off the stack too? When it goes out of scope? Just I get the data, right? The data obviously gets interesting. Why though? Because I thought once a function exits, it pops all the local variables off the stack, right? But it's not though, because it's created here in this case. I'm talking about this function specifically. This is a local, right? The reference, yes, but the S... No. So hang on. There's three entities, right? There's the reference, S itself, which is a fat pointer, and this data. When this function exits, the data gets destroyed. I believe S also gets popped off the stack. Or is it that the compiler sees it's a reference to S and it keeps it on the stack too? I think it has to be the second one. Like, maybe the compiler is smart enough to see that, okay, I had this local. Well, I mean, this doesn't compile, obviously, but... So let's do it this way. Let me ask you this one. So I know how to ask you because I know about the copy thing, right? So if I say, if S is an I32 and it's 4, and I return a reference to S, okay? So this will work now. What the heck did I do? Oh, sorry, it's I32, obviously. Sorry, a reference to an I32. Oh shit, it's also a reserved keyword, right? Yeah, you're right. Okay, this still doesn't compile. Even though this is a hard copy data. Interesting. I guess something they didn't cover is, I guess, so references. When a function returns a ref, it needs a lifetime. Okay. I'll save it for later then. Because S is created inside Dangle, S will be deallocated. Yeah, we try to return a reference to it. That means reference will be pointing to an invalid string. Okay, the solution here is to return the string directly. Yeah, this one is easy. Ownership. This is the classic moving ownership out. Okay. All right. Yeah, the given reference will only live for the function scope. So even when returned, it will point to garbage data. Ah, I think that one is more subtle, right? Because if I just, I immediately declare it and it also immediately goes out of scope. Even if the compiler would have let me get past this point. Yeah. Interesting. Okay, I think I'm done. Okay, I kind of wanted. Okay, what does the thing say? Please. Okay, I read all the stuff. Let me move on to move semantics. I better get these right then. Okay, fix the compiler error in this function without seeing it because I want. Let's see. So, Jesus Christ, what the heck is this? Vec. Problem is I forgot everything about Vex because we've been reading about ownership for like 1 year now. All right, let me take a quick break. I'll be back in like 30 seconds. And I hope I get these right. All right, let's see what's going on. All right. Um, okay, so what the heck they want us to do here? Fill a vec. I gotta push a value and return the new. Okay, so we know a vec is mutable. I mean, it's not even a reference thing, right? I can push to a vec. This looks like some weird shadowing thing. I would just do this. What the heck is going on here? Well, the test tells me that I gotta push an 88 onto something, right? That's pretty clear what they want to do here, but why would I shadow this? This looks wacky. Because if I shadow this, this is gonna get dropped out of scope when I return. Is it? Damn, I forgot. Really? So it's not this? It is not. Okay, then it's easier. Then I have to create vec. Oh my god, I forgot. Yes. So when you call let, yeah, so it is. I just need to create a mutable one on the fly. Okay, I kind of forgot about. I'm a bit confused. What I thought the whole point of vec was that it's not an array, so you can grow it. I gotta check my Twitch settings. Interesting. I guess. Okay. I kind of forgot about. Let's see. What was the hint here? The fixed word is going to be adding. So you've got the. Oh, clone. Okay. When turning call copy of the type X is trivially copyable. Okay. Like this, right? Because we want the hard copy, basically. And the hint for this was, so you've got the cannot borrow vec is not declared mutable on the line, right? The fixed word is going to be adding one keyword. In addition, is not on line when push. Try accessing vec 0 after having called fill vec. See what happens. So if I access vec 0 after call fill vec, I would not have been able to access it because yeah, return a vec. What do they mean here? So try. Okay, let me mess with this because I'm not happy. Hang on. What the heck do these guys want from me? So it will live outside the scope and was initialized in that. I can still use vec 0 here though, right? before and after. Like I can do print line. I can't use even. Yeah, I see. Okay, so this goes back to the thing where the compiler doesn't know. Interesting. Let me. What am I missing here? Did I forget something? Updating a vector reading. No, it's in the. Okay. All right. It's in the ownership. Let me try the next one. Let's see what's happening here. Not good though. Okay, so hang on. This I gotta get. So they say, I guess, am I allowed to look at the compiler errors? If I look, it'll be easy, but I kind of don't want to look. So we create a mutable copy, which is also a clone here. Sure. So I have vex0, and I need to be able to use vex0 and vex1 accessible at the same time to fix component error in the test. This one I know. Hang on. I'm just gonna take. Well, okay. I'm just gonna pass a clone. This is the brute way of doing it. And I think that's it. Okay, I got it. It's the crude way, but I understand it at least. Now, the real thing is, can we do this with references? And I believe the answer is yes too. Because I was gonna go. So what if I pass a? Yeah, exactly. There's two clones. So what if I pass a reference? I think this an immutable reference. I gotta change the signature too, obviously. But I don't want it. Why mutable though? Because how do I dereference this though? Like, can I do, is it star or what's going on here? Like, I can just do this then. And this should work. No. Oh, wait, this is something else. Vec has type. I thought Vec does have the copy trait. Because it's a vector of I32, so I need a clone then? Oh god, no. Something is wrong here. Hang on. So pass as plain ref. By plain ref, you mean immutable reference? Oh, okay. So this is all because I don't know how to annotate this. Oh, okay. Sorry. So it's not a reference to a vector. It's like a slice reference, basically, or also this variable thing annoys me like crazy because this is like, I don't know why it's shadowing it. So it's vec new. So I have a reference to a slice. Okay, hang on. Now, how the heck do I get the data under it though? Because I don't know the method. It's gotta be like vec dot into or something. Oh yes. Oh god. Yes, this is all the data. Yes, so this is, I get the data under it. But I don't have push now. So what is vec? Aha, I know what it is. It's vec from. I want to make a new vec. I know I'm overcomplicating this, but maybe I'm not. Hang on. And then I push and I return it. Or is it vec from directly from the reference? I don't know the method. That's the problem. What does it want if I do the from? And where the heck is the from? Oh, it's to vec. Damn it, I don't know these yet. I think you're right. Yes, it's the slice to vec, right? Okay, so now I get a vec and I push. Yes, it works. Okay. So this makes a lot more sense to me because I pass an immutable reference. I didn't know I didn't know about this part. It was not clear to me. You have to annotate it like this. I would have just done the dumb thing where I annotate it as ampersand vec, but that doesn't work. And then I create. Okay, so hang on. Is there an even better way? Do I even need to create? I guess the function signature wants me to return a vec, but do I need a vec or? I need something new because I can't push. Okay, yeah, because I think I'm pretty okay, but hang on, let's hammer this even more. So, is there a way to avoid the copy completely? Because here I'm making a hard copy. Not with push. Definitely not with push. So push, because they use the push here, they're forcing you to make a copy before. You're making, what do you mean for a copy? Just get the mutable I32. But I can't mutate because they want to, why would I don't understand the mute part. Well, they're asserting that vec0 stays the same, all right? So you're saying that I pass. So you want to pass a mutable reference to this? But then if I do the push, it touches the original data. Exactly. Yeah, it'll override vec0. Yes. So, okay. So that was my question. Good. So I wanted to confirm with you guys that there's no way around cloning here. Are we sure about that? Because kind of smells like, nah, but it can't be memory safe, right? There is no way to not copy. That's what I would think naively, but okay, I mean, I definitely agree, but just wanted to double check. You can get around using clone, but not really. Yeah, I mean, syntactically, this probably does a clone, right? Yeah, you have to clone the data. Okay. So there's no way to... Yeah, it has to be like that, because that's how Rust works. Like, I can't point to some data and more while reusing the same memory location, because I have big trouble then. Okay, I'm pretty happy with this. Okay, let's see the next one. Oh my god, it's gonna get way harder if this is 3. What the heck do they want here? Okay, kind of the same story. So they want to push, return the vec, fix the compiler error without adding any new line. And what do they expect here? So I take a vec 0. Okay, I just gotta push something without adding... Like, am I allowed to edit the line, or what does that mean? Like, okay, let vec. Maybe they're testing my inline, so I'm just gonna clone it, and I'll push to it. And I didn't add a new line. Except... Oh god, wait. Is this mutable? I feel like this is not gonna work, right? Can I call push on a clone of vec? I can't change this line, so I can't pass the mutable reference. I can change the mute, but I can't pass it here. Does that work? Or... Exactly, that's what I thought too, yes. So the output of the clone, yes. So something is weird here. Yes. So this doesn't look right. I mean, sure, this looks almost too easy. So basically I can just... I don't even need the shadowing then, right? Because I'm completely destroying V0, Vec0 anyways. Oh shit. I still need the clone though? Something is fishy here, yeah. So they started off from this. No, we started off from this. I definitely need some sort of shadowing. Let me just call this, because this annoys me like crazy. So we can do this. The thing is, this doesn't work. So it is on the type side. Let me try the stupid clone thing. Hang on. It is not. Why? Okay, yeah, this is nothing. Yeah, okay. This is... Oh, I know why. Because push is in place. Okay. Never mind. Yes. Okay, yeah. So this doesn't work because I cannot... Yeah, the clone will dangle. Yep, yeah. The clone... Okay, good. So it's not this. Okay, all right. Yeah. I mean, the compiler does tell me. So it's just the magic... Oh, I see. It's just the magic mute... Because it takes ownership, so I can do whatever I want to it. So then I just magically declare it mutable. Then I give ownership back. But on the outside scope, Vex0 is completely destroyed now. Like, I cannot use it anymore, right? Like, I can't even dare to print here. Or maybe I... Actually, can I even print here? No, I can't. Yeah, it's done. Yeah, because I borrow... Okay, so yeah, it's got moved. Yeah. Okay. So I can declare something mute. Yeah, exactly. I own it, so I can do whatever I want to it. I can mark it as mutable because it's... I moved ownership and then I don't take it back. Like, okay, I could take it back like this. Like, let Vex0, sure. Or like this. But then I don't take it back, so it's destroyed at this point. So I can... Yeah. Okay, definitely seems more complicated than what we read, by the way. Don't remember reading this, but it's good practice. Let me see what the hint said. Difference between this one is that the first line had let mute. No, not shadowing, but I could have actually assigned it. I guess I would have needed a mutable here too then, right? If I did this. Let's see. Yeah, this works too. It's just assigning a new name, which is going to the same name. Yeah, but it works. Okay, so not the shadowing, but like the actual mutable assignment works too. Oh let me see. We have somebody. Oh, thanks for joining on YouTube. I'm just messing around with Rust. Not too many clear goals. I kind of started learning from scratch. This is just the second stream. I think it's pretty interesting though with all the borrow checking stuff. Definitely seems a bit harder. All right, let's go to the next one. 4. Oh boy. Fix the compiler errors by reordering. No, I'm pretty happy with Rust. It is getting trickier, but I want to get to data structures too. I want to get more into the type system stuff. I think it's pretty interesting. Let's see this one. Fix compilers by reordering the lines in the test. Don't add, change, or remove any line. Just reorder. Sure. Move semantics. Oh, Jesus Christ. So... Yes, it's definitely... Yeah, it's definitely has to do with type Python for sure. Because I type everything in Python. So... This one's definitely the first line. There's no way. It's like a mutable vector from scratch. Okay, this one is easy. I know this one. This is trivial because I can only use like this, right? So this goes out of scope here magically. This goes out of scope here, and now my x has become 42, 13. And they're also in the right order, right? Because 42 is first, 13 is second. Push pushes to the end. Yes. Okay, yeah. So this is just about, I mean, we solved this before. I kind of guessed it. All right. Fix the compiler errors without changing anything except adding or removing the character ampersand. And I get some hint comments here too. Let data. Rust is great. ToString. Sure. Where am I supposed to do the fix? Anywhere, I guess. Oh god. Okay, this one's hard too. I can't make this mute, so I can only add or remove references. So, I guess it's in the functions and here if I need to change the signature, I gotta pass a reference. Let's see where. So, I got a string. Should not take ownership. Well, this is obvious then. It needs a reference. That's clear, right? I mean, this is it. And should take ownership. Okay, so then it doesn't have the ampersand. That's it. Because it says so clearly, right? Shouldn't take ownership. Data. Do I need to dereference this? This is what I don't understand. Like, I don't need to dereference this, right? To get chars. No, I don't, because we didn't learn about dereferencing yet. Yeah, okay. This one was... It was easy because it kind of gave you the... It gave us the hints in the comments. Let me see what the... Let me see what they say here in learning Rust by example. Is there not even like a... Yeah. Probably in bindings. Where the heck is binding? Oh, variable bindings. Oh yeah, you're right. Okay. Okay. I guess I can try to fix this one. Yeah, we can do struct. Struct should not be that hard after all this. Variable bindings are mutable. It can be overridden using the mute modifier. Before mutation, mutable error cannot assign a new value to an immutable variable. But this one's easy to fix. It just has to be mutable. Not that you're supposed to fix this. Variable bindings have a scope and are constrained to blocks the collection statement. Okay, this one's easy. Comparability and further type. Okay, so scope and shadowing. Okay, this one's easy. Shadowing. No, but it's not. The borrow checking is not here. I guess they don't have it here actually. It's supposed to be so basic that you're supposed to learn about it before. There's like no section for it. Interesting. Traits, bounds, multiple. Yeah, these scoping rules. Aha, ownership and moves. Oh god. Resource can only have one owner. This is where I want to get. When doing assignments or present functions to have the ownership of resource in Rust speak, this is known as a move. Moving resources the previous owner can no longer be used. This avoids creates dangling pointers. I mean, this is basically like the hyper summary of what we just saw. Copy X into Y. No resources are moved. Both values can be independently used. Okay, this is exactly the string example we saw, except with box, I guess. You can no longer access the data. Try and commenting this line. It's going to function ownership. Okay, this is the not a reference, so it takes the direct ownership, and it once it goes out of the scope, it's toast. Okay. Mutability can be changed when ownership is transferred. Ah, this is what I was missing. Okay. See, we didn't go through this. This is why you can magically change it in the function signature, right? Like you can pass something immutable. You can just move it and change the ownership and change the mutability. So I guess that's the mechanism behind magically putting a mute in a function signature. Interesting. Yeah, I saw the box. Yeah, I mean, I vaguely know what it is, but I think it's maybe it's not that far away now, to be honest. Yeah. Partial moves. What the heck is a partial move? No, this is too complicated, right? Is it like a part of a struct? Yeah, it's destructuring. Oh, within the destruct. Oh, we saw destructuring though. Destructuring is like a. By move and by reference pattern bindings. Ties implement drop cannot be partially moved from. Okay, there's let's not. What the heck is destructure? Okay. Oh, I see it's here. Oh yeah, it's the pattern where when we break a tuple into pieces. I guess it works for structs and enums too. Destructuring breaks up a value into its. Okay, I literally said this. The syntax is almost creating such values. In parallel, where the scrutiny has a struct and wildcard, etc. Rest. I need to learn all these terms too. I guess this is what they call the Rust reference. Holy shit. So what can we find in the Rust reference for ownership? Memory model. Okay, this is the ultra compact version. So the items are those functions that have their value calculated compounded stored uniquely. The heap is the lifetime of an allocation, and the heap depends on the lifetime of the box. Since box doesn't pass, heap allocations may outlive the frame. The allocation of the heap is guaranteed to live for the whole lifetime in a single location whenever you reallocate it. A variable is a component of a stack frame. Variable. Function parameters are immutable. Unless the mute keyword applies only to the following parameter. Okay, I could have used this too. Local variables are not initialized when allocated. Instead, the entire frame worth are allocated on frame and initialized state. Yeah, I saw this at FN. Local variables can be used only after they've been initialized. True. Okay, this I did not know you can do this. Like, after the if expression. Okay. All right, it's good to have the reference book too, because it actually kind of explains the terms pretty clearly. Okay. Let's see what they want here then. Yeah, it's the nothing type. Yep, I got that. All right, so structs 1. How many of structs are there? Oh my god, only 3? Okay, maybe structs are not that hard then. Probably not then, right? Rust has 3 struct types. A classic C struct, a tuple struct, and a unit struct. Okay, sure. Structs are similar to tuples. Okay, pretty obvious. Both hold multiple related values. Like tuples, the pieces of a struct can be different types. Unlike tuples, in a struct, you'll name each piece of the data. Okay, so struct is basically, why would you ever use a tuple? You don't have to rely on the order of data. Okay, to define a struct, we enter the keyword struct and then name the entire struct. A struct's name should describe the significance of the pieces of data being grouped together. Then inside curly brackets, we define the names and types of pieces which call fields. Okay. Struct fields. To use the struct after we've defined it, we create an instance of that struct. Okay, this is pretty Pythonic, like a Python dictionary. Nothing weird here. Key value pairs. String U64. String from. We don't have to specify the fields. We don't have to specify the fields in the same order. Very weird, but sure. The struct definition like a general template. We can declare a particular user as shown. Okay. To get specific, we use dot notation. For example, to access the users, user dot. If the instance is mutable, which I guess means I just magically put the mute here. All right, maybe it's time we start the thing then. So if I do a struct, oh no, the whole instance is mutable. Sorry, no, that's what they meant, yeah. So the whole instance is mutable. I can change anything then. Okay. The entire instance must be mutable. Oh my god, I actually got it wrong. Rust doesn't allow us to mark only certain fields as mutable. Okay, this is good to know. As with any expression, we can construct a new instance as the last expression in the function. Okay. So this is a function that returns a user just by building it on the fly. You need to declare the properties of struct 1 by 1 to public. Yeah, making it so, but yeah, we have a long way to go. I don't know if they're gonna talk about. Oh no, they will talk about methods. Okay. I guess that's kind of the whole point. It makes sense to name the function parameters with the same name as the. It makes sense to name the function parameters, yeah, but having to repeat email is a bit tedious. If the struct had more fields, using the field in its shorthand, because the parameter names in the struct are exactly the same. No way, you can actually pass this email and it magically, okay, I see. So if it matches the key, you can pass the variable directly, and the type it must match. Huh, interesting. We're creating a new instance. We want to set the email to the value, but it's dumb to say email. Yeah. Creating instance with struct update syntax. It's often useful to create a new instance that includes most of the values. It does, right? Yeah, it looks really ugly. Yeah, might as well just copy paste it. It's not worth it. And of course, we're not going to change the order of the fields. That is insane. Like, you always keep them in the same order, right? I don't understand why you would swap the order randomly. Okay, so there's an update. I guess it's user 1. You can update just a certain field. Oh my god, but it's so ugly. Really? It's dot dot? It would have been nice if we had a method on this struct that would be update, which I guess we're going to learn about next. Yeah, because this one looks really bad. The code creates an instance. Different value for email, but has the same values as the fields. The user 1 must come last. Oh, it must also come last. Oh my god, so it forces you to change the order too. Like email was the third one. Okay, we're not doing this for sure. The user 1. Oh, sorry. The struct update syntax uses equal like an assignment. This is because it moves the data, just as we saw. Oh my god, this is a move? This is because it moves the data. And we can no longer use user 1 after creating because the user was moved into user 2. If we had given user 2 new string values, both for email and username, it gets even more complicated. They're right here because the integers implement copy trait. So if I would have given, if I just copy integers, I can still use user 1, but because I moved something that's not copyable, it's lost forever, I guess. Stack only data copy. Did we go through this? Yes, we did go through this. We can also still use. Oh, but I can use a piece of it? Oh my god, this is so bad. Like, we can also still use user1.email, but not user1 as a whole. Okay, I gotta mess with this. Something is fishy here. Yeah, it is really weird, right? So what is happening here exactly? So I go... Oh, actually, I have it. Yeah, we went through copy. Copy only works for like the scalar types, but then if I... So basically what you're telling me is I can take user 2. So then I can actually say user 1 dot... No, this can't be because I cannot... So if I make this mutable, oh my god, it actually works. But I can no longer... Oh, I see. So they just mean the fields then. So then I cannot print... Well, I guess I can do it here. User1 dot email. Oh no, well, never mind. So the syntax doesn't work. Like this. I know why. Because I didn't do, okay, check this out. If I do user2, I didn't do anything to it, so the compiler still knows it's valid. No, but it wouldn't, because it's a move, right? I'm confused. What do they mean? So if I move the data, it's gone forever, but so in this example, we can no longer use user1 after creating user2. Oh, I'm so dumb. It's username is the one that's wrong. Sorry, not... Okay, there we go. Yeah. So I can no longer use user1 username because I I moved it into user2. But the interesting thing is I can assign it after, and now what happens? I can no longer use... It is pretty bad, right? Like now, but wait a second. Now I got it back magically. So now I can print it, which I guess it has new stuff. But did I lose user2 now? No, it's not tied like that, right? So if I now try to do user2.username, because it has its original data now, which should be some username. Okay, yeah, it is. Okay. Yeah, so in this case it is move. Now the other question is, had I done... What if I do this? In username, I put user1.username, and then everything... Well, okay, if I'm lazy, but I know these other ones are copy, right? So, okay, fine. Just for completeness, I can do this. But I don't need to because I know they're copies already. Do I still have username, user... I still don't have it. So even just the plain... Even a plain assignment is interesting. So even a plain... Yeah, so any kind of reuse is a move. Yeah, I gotta watch out for this pattern because it's pretty bad. At the same time, you don't want to clone the whole structure, but yeah. That's also, like, I can't do user1 clone. Yeah, this one seems... I don't know what I would... Yeah, okay. I mean, because string is not... So I can... Okay, so what you're saying is I can clone the string. No, I think this still... Okay, this works. Yeah, okay. Interesting. There must be even more special syntax then, because I guess it's not, because I can clone the underlying data. Yeah, the value. Well, manually, but it's not to do with... This is what you mean by manually? Because the problem is it's the same problem now. It's just, it's a field thing, right? Yeah. So I actually have to do a clone here. Although, well, I have to do it if I want to ever use user 1. Otherwise, I lost it forever. Which is probably, it's better to just implement clone for the struct at this point. Or maybe like a from method or something. Rust also supports struct. Okay, so there's another kind. Okay, tuple structs. These are basically anonymous structs, right? They don't have the fields. Yeah, they don't have name associated. If you have to clone the far bar checker, but if you want to clone all the struct, then yeah, this seems there must be a. But you know what? I think you're right. This kind of makes sense though, because how would you do it? You have a string, right? So it points to, it's a fat pointer that points to underlying data. So then because of the borrow checker, it has to be like this. Like it's basically exactly like structs are, they're just like light wrappers around, at least so far, right? So it makes sense that if you try to do this, it's gone forever. Yeah, maybe it's not so ugly. Like, it kind of makes sense, right? You couldn't do it any other way. Okay, so there's tuple structs which are anonymous field structs, except you just specify the data types in order. So we're going to give the whole tuple a name and make the tuple a different type from other tuples. And when naming each field, yes, so define tuple struct followed by types in the tuple. Okay, sure. Like an origin are value different types. Yeah. So even though these appear identical, there are different types in the type system. A function that takes a parameter of color cannot take point. That makes sense, even though types are otherwise tuple struct are similar tuples and can destructure them with the dot notation. Unlike tuples, tuple structs require you to name the type of the what? To name the type of the struct when you destructure them. We would write. Oh, interesting. You can unwrap in like 3 variables at once. Let point. Interesting. You can unwrap into multiple unit-like structs that don't have any fields. These are called because they behave similarly to the unit type, which we did not cover yet, I guess. No, we covered this somewhere here. Okay. Unit-like structs. Parent syntax is so yes, it is. Yeah, this is very Pythonic, like to unwrap something. Yeah. Unit like structs can be used to implement a trait on some type but don't have any data. Okay, so it's like a zero size type. Here's an example of declaring. Okay, so it's a unit struct. And this is a type now. It's not even an instance of it, right? Oh, no, it is an instance. It's an instance of always equal. Any instance subject to every unit that present no result. We will need any. Okay, we gotta go to. Okay, so now they talk about the ownership, which we discovered ourselves, or that's what we were messing around with. In the user struct, we used the own string type rather than the string slice type. We want okay, so this is the fix. Aha, wait a second. So there is a nice fix. This is a deliberate choice because we want each instance to own all of its data, for that data to be valid. It's also possible for structs to store references to data, but to do so requires the use of lifetimes. Okay, I did not know this. Okay. Interesting. Lifetimes ensure that the data is valid for as long as the struct is. Let's say you try to store references naively like this. Probably not going to work, right? Yeah, okay, so I think we've seen this before. Okay, an example program using structs. To understand what you want to use struct, let's start a program that calculates. You just have to assume those the fields. Yeah. I see. So then it acts kind of like a scope or a function, basically, except it's bound to the instance of the struct. To understand where we might want to use structs as a program because the area of a rectangle. Start by using single variables. Okay, let's make a new binary project with cargo called. Okay, so we have this. Okay, sure, it's basic multiplication. The code succeeds in figuring out the area by calling the area function with each dimension, but we can do more to make this code clear or readable. Okay, so you just want to make it take a tuple? Blah. In one way, this program is better. Not really. Tuples don't... Yeah, obviously you want a struct. Well, shit. Let me try to do this then. I can do it. This one's easy. It's like struct rectangle. Width. I32. No, U32, because it can't be negative. Height, U32. Okay, and then we say let rectangle is rectangle. I forgot the, I guess it's like this, right? Width 30, height 50. Shit, okay, so I'm gonna hit this then. Let's see if I hit that. So then rectangle, and you're saying I cannot do a rectangle dot width times rectangle dot height. The area of the rectangle is area of rectangle. Let's see. It seems like it works. Are they public by default? Or what's happening here? Interesting. But I'm guessing this is... looks pretty clean to me, not sure. Pub is like file scope. Oh, so inside the file is it's public always, right? It's cross modules that you need pub. That sounds about right. Otherwise you would never be able to use anything inside the same module. Yeah. Yeah. Okay, so then, oh my god, I guessed it. Oh no, I messed it up. Why do they do a reference? Holy shit, I messed it up bad. God. Because it has to be, I destroyed the rectangle. That's what I did. Because if I now try to print, no, I didn't destroy it because it's a copy. All right. So, okay, I got away with it. No, but that's the thing. It's a copy here, right? So if I try to do this, it still works, I believe. Yeah, but it is bad code. Yep, I got away with it by accident. It does. No, I didn't get away with it because the whole rectangle get. Why is it not a copy then? So when I move the rectangle into the function, it's not a. I thought these have copy, right? Interesting. Ah, because it doesn't have copy for the. So okay, so copy. Okay, yes, I know what. Well, you're right. It is. What is it? Derive, copy, and it's auto derived, right? And I guess clone too. Yep, there we go. Yep, okay, so a struct is a custom data structure, so that it doesn't auto-derive these, even though it could easily in this case, it doesn't. Copy needs clone. Okay, I see. So it doesn't work just with copy, I'm guessing? No, it doesn't, yeah, okay. Okay, good. Now, of course, that's the thing. This is the bad way anyways, because I really should have done... God, I need to get used to the references, right? So we need take a reference to rectangle. And that's it. Now we're clean. Yeah, this is the right way because we don't copy any data. Okay, still gotta get used to borrow checking then. That's good though. We use structs, but I can transform the tuple. Messed up. Okay, we define the struct inside the curly. We define the width. Our area function. We want to, yep, as mentioned in chapter 4, we want to borrow the struct rather than take ownership of it. This way, main retainism can continue using rect1. I'm surprised you don't talk about performance here too, because you're avoiding a copy. The reason for copying clones is you can just use clone and will abstract to copy as you can call. I see. You can't call copy method. The area function, okay. Calculate the area, okay. Adding functionality with derived traits. Holy shit, we're already here. So if I try to print... Oh, is this the nicely print? It's a nice print trait, right? The format thing. We've seen this before. Yeah, we can do a debug print, or we can derive the trait we... Okay, hang on. What the heck is going on here? It's useful to print an instance while we're debugging our program. So we can't do the pretty print because it doesn't implement display. We saw this last stream. The print line, blah, blah, blah. Primitive types we've seen by default. With structs, the way print line is less clear. Do you want commas? Sure. Should all the fields. The print macro call. It also doesn't implement debug. Oh, God. Oh, we can just derive debug on it. Okay, so then this will pretty print it. We can say rectangle is rectangle. Okay, and it looks pretty nice. I like the... Okay, it prints the name. It's actually exactly the struct, basically. Now when we run the program, we'll see the following output. Yep. It's not the prettiest output. It shows the values okay. Oh, interesting. We can use this to what? To pretty print it more? Yeah, we can. Okay. Another way is to use the dbg macro, which takes... ownership of an expression, which prints true standard error. Okay. We know what, yeah, okay. It prints the following line number. We gotta be careful to use DBG. On a reference to a rectangle, because it takes okay. Sure. Okay. Methods. Okay. So we declare them with the function implement. They have parameters, they contain some code that's used. Unlike functions, they're considered okay. Okay, this is like the most Pythonic thing ever. It's basically ripped off from Python. Yeah, they're only separate blocks, but then self is like, if you know Python, it's like they're basically stolen from Python. It's gotta be, right? It's like a reference to the instance. Okay, so we can implement the area directly here. We don't need the function anymore. And let me guess. Well, actually, let's see. All right, so now comes the test. Because this takes a reference to self. What the heck? So how do I call this? Like rectangle dot area? I don't need to reference. I mean, it's not reference to rectangle dot area, right? Because this trait what the heck is going on here though? Hang on. So attempt, oh my god, it's a method. I'm so dumb because it's a function call. Okay, there we go. Yeah. It's not an attribute like in Python. Okay. All right. So it's rectangle area. A method can either take self or not. Okay, so it's not quite like Python. I guess it's optional. Yeah. With you mean with this, right? The rectangle area from rectangle. Aha. Now I need a reference. Oh my god. Hang on. We almost fell for it. Well, we did fall for it. Now I need a reference because it wants a reference to an object. See, even you fell for it. It's Rust borrow checking is gotta get used to it. So there is a difference here. Yeah, I know it's but it makes sense. I like this because it forces you to think about the borrow checking. And I guess here's the other thing now. If I do the naive thing and I do this and then I do this, I destroyed my rectangle because I don't implement, right? Yep, I did. Yeah, exactly. So I gotta be careful here. I definitely need a reference in fact, I always need a reference here because even if I do the other way, like rectangle dot area, and I don't take a reference, I destroyed my rectangle. Yes, I did. Okay. So very important here. In fact, it seems like you always want this then, right? Like you would have to be, insane to do this, or not always? I guess why? Because you want... I guess, sure. Okay, so what? You can return yourself, right? Sometimes you want self because you do stuff and you give it back, like the manual way. Decorator logic. Okay. Interesting. Or yeah, I mean, you can always do it the manual way. You can give yourself back ownership, but yeah. Okay. Yeah. Oh, yeah. Return a new instance. Yeah. Okay. Sure. Interesting. Because I guess that guarantees you destroy yourself, and you want to destroy yourself sometimes. All right. So pretty good. I think we guessed this. Yeah. Yeah, it makes sense. It's pretty... You can do anything you want. Here they call it with rectangle. Define the function with context to start impl block. So impl rectangle, yeah. I guess there is another note here. They use self instead of rectangle. The self is actually short for self. Okay, sure. I see. So there's a special type called self. Interesting. Within an impl block, the type self is an alias for the type. Sure. Methods must have a parameter named self. Ah, no. So it is exactly like Python. They must have a parameter. You cannot get away from this. Right? Or maybe, oh, maybe it doesn't have any parameters. Maybe that's what this means. If it has any parameters, the first one must be self. Anyways, well, that's probably not that important. Although we still need to use the... Well, we can actually try that. No, but what would it do? Like what? Return 4? 3? It doesn't work. It wants self, right? It must have a self. Oh, it's an associated function, not a method. Okay, I'm discovering stuff that is probably something else. Yeah. Interesting. Not sure what an associated function means, but whoops. All right. Yeah, that smells like Python too. Yeah, like a class method instead of instead of a method. Okay, like methods associated with the class, not with instances. All right, it's definitely stolen from Python. The self is actually for self. Know that we still need to use ampersand. It's a selfless function. Methods can take... Oh, we saw this. We did the naive way where we take ownership of self, borrow self immutably, or borrow self mutably. We didn't try this one. Interesting. So I guess everything is possible. I could have also done... What the heck is the notation? Is it ampersand mutable, right? So I can do a mutable reference for self, and then I can magically change the width to 15 and return this, and I changed the rectangle forever now, right? Yes, I did. But wait, I need to make this mutable then. Wait, do I? I think so. Right? It's gonna... Okay, so here's my bet. It'll crash. It won't let me do this. Yep. So then I need to put a mutable here. Okay, good. It works like I thought it did. So 15, I changed the width to 15. 15 times 50, 15, 50. Yeah, okay. Good, 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 good. Okay. All right, next. We choose self or single user. We don't want to take ownership. Okay, so we went through this. We want to read the data. We want to change the method. Okay, we also tried this just now. Having a method. Aha, this is what I discovered. I was trying to discover earlier. Having is routines usually using the method transform. Okay, there we go. It's what we talked about in chat. When the method transforms cells into something else and you want to prevent, it's also this, because you could also transform it with a reference, but you also want to, actually I was wondering about this, you want to prevent the caller from using the original. So my question still stands, when the heck do you want to do this? Interesting. So it's like you're forced to use what I give you. If you don't implement copy and clone, they can't. Interesting. The main reason for using methods, and it provides the methods, not having to repeat the type of self, is for organization. Set logic occurs in DSL. What is DSL? Domain. Oh, domain specific logic. Yeah, okay. Interesting. We've put all the things we can do with an instance of a type. We can choose to give a method. This is the worst thing ever. We can choose to give a method the same name as one of the struct fields. Seriously? You will want a 50%. Yeah, I see. So you want a method that completes something and then you don't want to... Yeah, you want to prevent the partial from being used downstream. And you can do that at compile time, basically, in Rust. Makes sense. Interesting. I gotta get used to thinking like that. Pretty interesting, actually. Yeah, so giving a method the same name as one of the struct fields is like... No, I'm never doing that. What method returns self is the iterators. I don't... Yes. We're choosing the with method to return true if the value instance is greater. Okay, I'm not doing this pattern anyways. Oh, this is that chaining, right? I see. So then you can chain it that way with others, right? Because it returns an instance of self. And that's why you can chain it with others. I think. Yeah, exactly. Yeah, that makes sense. Very Pythonic. Yeah, okay. So we're choosing to make the with method return true. We can use, okay, I don't know what, I'm not doing this ever. Often, but not always, when we give the method the same name as a field. Oh my god, this is so stolen from Python. Like, I swear, like Python has had getter setters for years. Rust does not. Okay, fine. It's like, as some other languages do, sure. Getters are useful because you can make the field private. Yeah, this is exactly Python. Which I'm guessing Python stole it from somewhere else, but it's the most popular now. We'll discuss what public and private are. Okay. Where is the return type operator? No, this is something else. What the heck? Oh no, this is the C. Wait, this in Rust, this is return type. Why are we talking about this? two different operators. You use dot and you use arrow if you're calling the method on a pointer. Well, I would hope Rust doesn't have all this stuff. Automatic referencing and... But then you can declare a getter for the... Yes, Rust, you just create a function that returns the copy data, so you can or can't change it. I guess what you're saying is, so Rust doesn't have the setter part, because Python also has the setter part. Well, I guess you could write the setter method too. Yeah. Rust has a feature called automatic referencing and dereferencing. Calling methods one of the few places in Rust. Here's how it works. Holy shit. When you call, for example, string push requires a mutable self, but you don't need to do... That's a good example, right? Because string push is in place, right? So... When you call a method, Rust automatically adds so that object... Oh my god, so it does that... And it knows which one to put? Yeah, I think this is pretty important actually, because this explains a lot of things. Like you can call either string dot something or mutable reference to string dot something, and they both work syntactically. But that's because why? Somebody implemented that for string specifically, or the compiler figures out... I guess it depends on the method, right? Given the receiver and name of a method. Ah, okay, here it is. Rust can figure out definitively whether the method is reading self, mutating self, or consuming. This is pretty big, actually. Yeah, it explains a lot of stuff now. You have to give it permission. Declare var... Yes, the outer variable, like we did in the example here, right? So it still has to be mutable. So this is the permission part. And pass as ref. But see, this is the trick here, because I could... Like, I don't need to do this, right? Wait, I think we... So I don't need to do, like, this. Although this works, too. No, it doesn't work. God damn it. I got tricked by the borrow checker again. Hang on. So cannot borrow... I'm so dumb. It's so I can do this then? Yes, okay, you're right. Damn it. I see. But this is all sugar basically, right? Because the compiler is smart enough to do exactly the same thing with this. Which means it automatically passes in that mutable reference because it sees the signature here. So either I put it for it or it does it by itself. Yeah, This is pretty good though. This explains a lot of stuff now. Holy shit. I feel like I finally get a few, at least syntactically I get, because I always see like sometimes they do it this way, sometimes the other way, but, and it's always like it, I mean, well, no, it's always like they just call the method directly without. I think I'm wrong though. I think this is something else, right? This is... Is this like a double indirection or what am I doing here? Like, I first take a mutable reference, then I call the area, which inside takes another mutable no, it's not going to work like that, right? It's not... no, because the borrow checker would yell here, right? So I'm just, this is all just take a mutable reference and do this thing. It must be. But see, this is what I don't understand because I don't give any arguments to area, right? The first one is a mutable self though, which implies what? Self is... the variable from which I... This has to be sugar, right? Because self is rectangle here, not this whole thing, right? Because if it would be this whole thing, I would end up with like this. Yeah, I do not end up like this, right? Do not end up with this internally. It's not a double... because it seems like it would be. Yeah, exactly, because the borrowed... You can't do this. Like, oh, by the way, this is not Rust, right? Like, yeah, obviously it's not. It does. It must be mutable reference of type self, but where does it take it from? Because if I do a rectangle, it's pretty clear that it's mutable rectangle. But if I do this, I guess the type of this is still a rectangle, so then it's still a mutable rectangle. And this doesn't do anything. Nothing bad, I mean. Okay, I'm pretty satisfied-ish. Methods with more parameters. Yes, I am. Yeah. I think I am. I think so too. Yeah, I just needed to understand. But okay, that's good to know. Yes, I think that's how the compiler works, which is good. Methods with more parameters. What the heck? Oh my god, can hold. I can implement this by guessing it. So, let's see. So, can a rectangle hold another one? Well, you need yourself, and you don't need yourself mutable, obviously. Let me remove this hack here. And you need another rectangle, right? So, other... I'm gonna use the self type here, which I think is idiomatic, right? And I'm gonna return a bool because this is a generic method. And we'll say, oh shit, I need to do the math though. So when can a rectangle hold another one? If self dot width, if you're smaller than the other one, Is there a min in Rust? How the heck do I take the min? Use standard compare. Do not use self. Okay, so I made a mistake here, because to me this seems pretty nice. Like I compare myself with some other self. Interesting. I would have gone for self here. Why don't I have the type here highlighted? Interesting. I guess it is white highlighted, sure. Rust min of 2 integers. Is it CMP AB? Okay, CMP min. Yeah, this seems nicer to me too. It reads better, right? Because you have yourself and you have something else that's also self. But sure. Sorry, I gotta do some math here. So if my max is less than the... I'm trying to determine if a rectangle fits in another one. If my max... I can return a false, so I don't fit. I think it's trickier because you don't know which one of W is bigger, right? Well, you can have like... So 10, 100 fits in... It is, but the you don't know which one of the two is... Let's think about it. So I can hold it only if... What, both my sizes are larger? That's it? It's both my sizes in any order are larger. So for that to happen, I need my min to be greater than the other min, and my max to be greater than the other max. I think this is what it is, right? So if my min is greater, well, if it's smaller than my other min, it's false. If my max is smaller than the other max, it's false. Otherwise, it's true. Because I need both my dimensions to be higher than the other one. But I don't know which is which, though. You can break these down in pieces, but it's going to be a lot of code, right? It's not that easy. I think this is it. Let's try it. Let other rectangle. So for example, if I put a 40, 30, I can hold this. And I have what? Let can hold boolean is rectangle can hold other. I almost fell for it again. Reference. So I need a reference here too. Right, because we don't want to destroy the rectangle. Okay, semicolon, semicolon 2. Is it not Boolean or what's happening here? Why? Expected empty type? Found Boolean? Oh, but it's if without else expects their inner expression to be... I guess we have to do it this way, right? Not quite sure what it wants here, but... Like, it wants it like this? Okay, so let's see. Can hold true. If I put this to 60 or 70, should not be able to hold. The function is fried for sure. So my min is... But my min is small. Oh my god. I didn't use other. Hang on, it's way easier than I thought. So it's other. All right, there we go. So now 40, 20 I can hold. 20, 40 I can also hold. 30, 50 I can hold exactly. 50, 30 I can also hold exactly. Because again, you don't know which is which. Yeah, it's not that easy. It doesn't matter which, right? Like these two both have to pass. But 51, 30 I cannot hold. 51, 29 I can also not hold. 129 I can hold, etc, etc. Okay, so I don't know how the book does it, but I'm pretty sure this is the shortest way to do it. Yes, exactly, because that's all it says. It's can a rectangle hold another. It doesn't say which... it didn't say if they're in the plane. Maybe I got it wrong, maybe not. Let's see. Maybe I got it wrong. Maybe they wanted to do it the easy way. Okay, they did it the easy way. Yeah, I did it with the rotated way. Yeah. Okay. Anyways, it was good practice. So it was good thing I caught this reference. I would have fallen for this almost, but I caught the reference now. So okay, pretty good. Pretty happy with this. Associated functions. Oh, we discovered this by accident. These are functions without self. Okay, like constructors. Okay, so we can do one ourselves. So rotate should return. Wait a second, what's the verdict on the self though? Okay, so it is rectangle. Okay, so it's not self. I guess it would have worked with self, right? Wait, actually I'm curious. Is this a special type and it would not have worked at all? No, it does work. Okay. Except they want rectangle though. Interesting. All right, so let's write, we can write our own So something that doesn't take... Wait a second. So what does this do? What do I construct from? Oh, I see. I need a constant or something. I can't rotate myself because I don't have self. Okay, so rotate doesn't work. Never mind. Yeah. Yeah, it is curious because here I pass a rectangle, so it does recognize it. Like outside, you mean outside the module or? Yeah. Okay, so I can't do rotate. I'll just do like a square like they do, I guess. Square size U32. So then what? I return rectangle with width size and height size. And I do a square. And I guess I call it rectangle square. 30. I need the debug thing. Which is obviously not this syntax. It's this derive debug. Okay. And let's see if we got this right. Println question mark square. Looks about right. Okay, except it's called a rectangle, which is very unfortunate, but we can't change that, I guess. A square is a rectangle. Oh my god, they use... I'm so dumb. I should have used self here. But wait, why would I not use rectangle here then? I don't like the stylistic difference, but sure. I guess we'll use self here, but not in arguments. Okay, still a rectangle. Self here, appreciated by factor aliases for the type. We use this colon syntax with the struct name, blah blah blah. Okay. The function is namespace by struct. Yeah, it's just convention. Yeah. Oh, it is, you're right. Oh, no, this is something else though for modules. Okay, multiple impl blocks. Okay, so I can split this in impl. There's no reason. Okay, I'm pretty happy. We'll do the quiz and that's it for today. I have a feeling this is gonna be easy now. Let's see, because we went through a bunch of stuff. Okay, so color, regular, color tuple. Oh, gotta start reading this. So... Okay, so they want red, green, blue. Okay, so I can do this. Let's see. So they want red, green, blue. Pretty easy, nothing to write home about. And here they just want a bare triplet, I guess. And we'll do a green, which is color, regular, struct. Can I do this? Oh my god, you're right, I messed it up. I guess they didn't give me the types. Yeah, it's U8. Yeah. Is there a fast way to do this? Like if I do this, it doesn't work, right? It doesn't put the fields in order. Or does the shorthand work here? Like to initialize without writing the... No, because that's the tuple thing, right? So if I do the tuple version... they're definitely in order. Yeah, okay, so you would need a constructor. That makes sense. Yeah, for struct, at least for now, we need the keys. Okay, so it's just red. But I can't write them all in one line, though. At least, right? Green, blue. Spares me some headache. I guess you do it this way. No, I cannot write them one. What did I do? Oh, there's more. Oh shit, sorry. Let unit struct. I forgot what the unit struct is. What? Oh, it's just the type. Nothing. Not sure what I'm supposed to learn from this, but I mean, what? There's no assert. Okay, sure. I guess there's a funny hack here because this would have passed with everything. No, it would not have. Never mind. Why does it not pass? Wait a second. Is there some trickery here? Because i32s don't have the debug implemented? Oh, because it prints the type of it, or it prints it as a type. Wait a second. So if I do a string here, I see. So there's no way to hack this then, because it passes the type exactly. Interesting. So you can assert if the type is exactly that at runtime. What the heck is happening here? Interesting. All right, next. Oh my god, there's so many fields. Name, year, made by phone, mobile, email, item count, create order templates from whatever. Create your own order using the updates. Dude, what is this? So create your own order. Name, year. Like, they just want me to make a struct, that's it? I guess. It's a bunch of typing though, but sure. Name. Oh no, I'm so dumb. They want, exactly, you're right. They want to use, they want you to use as many pieces from this other one as possible. Hey, thanks for joining on YouTube. Let me put you on the, somebody's asking, is Rust hard? So, no, I'm here. I don't know if Rust is that hard. It's pretty hard. Today was the first stream, well, it's my second stream learning it. And it did get harder. It's the first time I failed some of these exercises. It was a bit earlier. Kind of messed up a bit on the borrow checking. But yeah, it's more like it's hard to get used to. I did fall into some traps earlier. Yeah, we're learning. It's just the second stream. All right, so they want us to create this. Okay, so I need to look at the template. So for example, I cannot use... I gotta do the string from... Rust thing, gotta use Go for async stuff. I guess you're forced to reason through all the threads and everything. Year, they want the year. Oh shit, it's everything except the count though. So then I can go count 1 and then I can use... Okay, yeah, this is what they want. Was there a comma after this? I'm gonna guess yes, because that's what sane people would do. And I forgot the semicolon. That's my fault. There's no way. There's no comma after this. No, it's not. Look. Remove this comma, like literally. It's not in this syntax. That's what I meant. Like, the syntax is wild. Like, I can't even put a comma here. See? Like, not only is it bad, I can't even do like the comma thing. Yeah, I know. All right. All right, next, last one. Oh god, is it like 15,000 fields again or something? Not really. Struct contain... Okay, so now we're talking about impulse. Can also have logic. We have defined the package and we want to test some logic. Country, recipient, weight in grams. Panic, okay, sure. What do they want me to do? Add the correct return type. Okay, I gotta read what they want though. Jesus Christ. So, can I guess? I'm just gonna guess from the name. So, because that's what good programmers do. They don't read the docs. Is international. When is it international? When the sender country is not equal to the recipient country, obviously. So then obviously this is a bool because it's is. And we'll say if shit, how do I compare two strings though? Is it just not equal? I actually don't know the logic. I know, but I'm just messing around. I'm trying to guess it just from the names, which they are well written. Like you can tell what this is. So if it's not, it's a false. Else, it's a true. The only problem is I don't know how to compare two strings. Is it just not equal? That I don't know. We have to read the docs for that. So Rust, how to compare two string. So it is not equal. Okay, so equality works. See, the thing is I don't know this because I see, there's a lexicon. Abstract out the if block to just the expression. Aha, that's smarter. Damn it, you're right, because it's exactly the result of that, right? Good, yes. So we need to exactly return if the countries are equal. And that's it. Yeah, my bad here. Okay, so that's it. This is the same answer as this. Do I need to put... No, right? It's literally directly this. And get fees. I'll bet you it's a U32 because you can't have negative fees. No, because it's... You're right, yes. Yes. It's international. See, we understand this without seeing the tests. We're just guessing from the name, which means... Whoever wrote these, they wrote nice templates. The problem is we can't guess this one. I have no idea what the fees are, so we have to look at the test. Thanks for joining on YouTube while I learn Rust. Mostly messing around. I do want to maybe do some... I had some ideas of game development, but it's going to take a while. Like backend for a game. Well, shit, they want us to do the math? I don't understand, like, how are we supposed to guess the fees here? So, cents per gram? Oh, boy. So, for 3 cents, it costs 4,500. Yeah, people are curious. I think Rust is really popular. I think so. It's cent per grams times the grams. It looks like it. But what the heck? Yeah, okay. Oh, yeah, you're right. We could have guessed this. Never mind. Okay, so it's just cents per gram times self. Ah, we should have. Okay, that's it. These are just one-liners. Okay, we're done. Pretty good. Enums, strings. I think I'm gonna leave enums. Let me see. Yeah, it's getting late, so I think I'm pretty happy with structs. We implemented our first traits today, which is not little. Those was actually the first traits I ever wrote in my life. I don't think I'm gonna do enums now though. Is it bad or? Yeah, let's do it tomorrow. I'll be live tomorrow about the same time, like 8 p.m. Pacific or something, 7 p.m. Pacific. So yeah, thanks everyone for sticking around. It's been really nice. Got into a bit of a snag with the borrow checking, so I'll be curious to see how much I remember tomorrow. But I think once we get into enums, the more we go through the issues, the more I'll get used to them. So yeah, thanks everyone. Thanks for the follows, likes, and we'll see you next time tomorrow. Bye. Have a good night.